Oh, I'm sorry. You thought it was gonna end, didn't you? No! It never, ever ends! You want to get off Mr. EJ's wild ride? Well, you can't! Ha! Slide, man. No? Alright, we stop. How's everybody doing? Hope everybody's doing well. I am running a 2-light setup today because I'm not turning all the lights on in here. I am very worried about overheating equipment. It is hotter than it was yesterday, but it's actually staying pretty cool in here, which is good. I got all the fans moving the air around. We got the gear jammer truck on Starbase Live. I looked up and saw it. There's the gear jammer. I don't know, I just thought that truck is cool. It's got a rake to it, and it's blacked out, which is pretty cool. It's the Yamati Express. The frickin' gear jammer, dude. That thing is sick. Love that thing. Hell yeah. Looks like something out of Mad Max, dude. That thing's awesome. Why the cap still? I know it's kind of a thing, but that's going to be heating your noggin for nothing. All right. You can have it your way, Dr. Bankman. Actually got some hair growing back. That's actually kind of cool. All right. So, what are we doing? What are we doing? Kerbal. That's what I said we were going to do. So today's stream is going to be a little weird. It's going to be a little long. And I had this crazy idea, and we'll see how well it pays off. Your mic seems a little bit off, switching between the left and the right channel. I can listen to other stuff normally. Here we go. It's the fan and the compressor not being happy. It is showing a little bit of preference on the right channel. How's the back today? I'm fine. I have a left-right mixer here. Hold on. Let me mess with it. So we are going to test mixing the channels. Oh yeah, we're going to test mixing the channels. We're going to test the... Oh, there it is. Fixed. Hey, Vesper, what's going on? Okay. Yeah, shouldn't have a problem there. I'm not sure why that's doing that. I'll bet that it probably has something to do with the fan blowing on it. But yeah, that should be nice and equal out. Yeah, very nice. How's the temp in the office today? It's gone up since I started streaming. 26C right now. Or about 80 degrees. I might shut off the lights, dude. It is cooler in here. The reason why I think the reason why the channels are getting screwed up is because the fan's blowing on the mic and it's moving it. It's not, the shotgun mic is directional. It's not picking up on it, but it's actually moving the mic back and forth. Open the door? Are you out of your freaking mind? You know how hot it is in that damn shop, dude? I'll be amazed if this camera actually loads. I have all the lights off in there, dude. It is so freaking hot. I'm a little bit worried about breaking something, but have you tried turning off the sun? Well, that actually gives me an idea, dude. Um, that actually gives me an idea. So what I was thinking is play Kerbal now, right? And then do Space News, and then I want to go all the way to the AX4 mission, or at least we're gonna try. I might end up having to take a break because it's so freaking hot. But I was thinking like work on the car at night when it's not, like 92 Fahrenheit out, like when that's not a thing, when it's not above 30°C. So like work on the car after Space News. Turn on the dang fan in your office. I, I just said like 15 seconds ago that it was on. Are you serious? I just told you that a moment ago. But why male models?
Discovery, go at throttle up.
Or you split? If Oglex, whatever it is, it's good now. What do we got here? So my back is good, guys. The only thing that's really holding us back from going in the shop is the heat. I actually feel great. Like, look, dude, we can. If I tried to do that last week, I would have died. I probably would have had to go to the hospital. Anyway, ADF rookie temps. I survived Marrakesh last week at 116 at 70% humidity. If you go there, you will die. I drove through the desert last year at this time in 112 with no air conditioning. Believe me. I know heat. I don't mind the heat. I really don't. It doesn't really bother me. I'm honestly worried about frying something. I'm worried about frying the computers. My computers generate a ton of heat because encoding in high definition generates a lot of heat. I missed part 1.1. What'd you miss? You'll see. Maybe you should go watch. Maybe you should go watch. No. I'll tell you in a second. Do a nollie inward heel. Skateboard. Skateboard. Yeah. Bet you weren't expecting that. Nope, back's fine. Told you, no back pain. My back is totally fine, Ador. Yeah. Yep. When you leave the board on the ground, it's fine. Sorry, I didn't look. What did you do? I would have died laughing you screwed that up and did your back in again. No. More like Eric Costin's Space Administration. Few will understand that reference, Methane, but I understood that reference. Do a kickflip? I just did! I'm not going to break a hip. Not on the board, dude. Yeah. So I was thinking we could play KSP now, right? we could play KSP now while it's the hottest, and then after, like on the other side of Space News or something, then we go out into the shop and work when it's not Satan's butthole hot, to use chat terminology. Paul, how you doing, buddy? So I figured that gives us a nice open time to work on the car when it's not ridiculously warm outside, and yeah, we can go from there. Well, now, blaming us, but it's kind of your fault, you know? It's kind of your fault. I kind of like this idea. Do not work on car in Satan's butthole. Ernok, it started doing the thing again. Bluefist did. Speaking of working on cars. So, I don't know. Dude, I drove it all around for the weekend, and then it started doing the thing again. It was not happy in the heat today. So, I don't know. We'll figure it out. We'll figure it out with what came in the mail. So, yeah, solid plan. Solid plan. All right, cool. Sweet. So, let's fire up KSP, which is really not a good idea when it's so damn hot out. But, you know. I know you were playing yesterday, but can you tell me what the name of that map you're playing Yakograd on is? A New Republic is Born is the name of that map. We'll be there in August. We'll figure it out. Yep. Are you buying some Banda from IKEA for getting in shape? I don't understand what that sentence is. All right. Do you also play Roadcraft? Johnny, I played Roadcraft a little while. I kind of got bored of it, dude, to be honest with you. I don't really... Roadcraft is cool, but I get the feeling it's a game about building roads by people who have no idea how to build roads. So I didn't really like it because it's not really realistic for building roads. And before people say, well, it's not a game for you, it's called Roadcraft. It's a game that literally has road and craft in the title, and you don't build roads. Like, you can build roads, but it's not realistic at all. Why would someone do that? Building roads in Minecraft is more realistic than that. Yeah, it's not that it's a bad game. It's just So Johnny, to be very clear, I don't necessarily mind Roadcraft. My thing with it is, like, I play STEM games on stream. I play games that need to have some layer of complexity so I can use them to explain things. Like in Kerbal, I use Kerbal to explain how to build rockets, right? How rockets are made and how rockets work, right? That's what I do. In Roadcraft, if the road building is unrealistic, I can't really use it to explain anything. I can't use it to teach anybody anything, which is a little bit of a problem for me. That's a little bit of an issue for you, boy, you know? What's the craziest thing in KSP that you have that actually works? Oh boy, the screen is not happy. Here, let's switch to the other chroma. That's even worse. Yeah, I'll just turn on the lights. It's gonna get hot in here. We're gonna play Kerbal, so fine, whatever. Is Hearts of Iron on the ticker someday soon? Do you want to play Hearts of Iron? There's some YouTuber administration YouTube. I mean, what we're building now, Andrew, is actually going to be pretty cool. I'm building a rocket that we found in an obscure NASA technical report called a post-Apollo Class 1 rocket. It's basically the rockets that were going to be needed are the rockets that the Apollo engineers thought were going to be needed after, like, we extract all usefulness out of the Saturn V. It didn't really have a name, so I named it, for our Kerbal rocket, I named it Prometheus. There is kind of a mock-up, an engine configuration for this rocket. That is the size. Melt check, how's it feeling in there? 80 degrees, Bree. But the fans are blowing, I got the fans moving air around. It's not bad. It's warm in the garage, though. So, Bree, what I was thinking is we'll, you know, play Kerbal, and then we'll do space news. And then later in the night, because the Axiom launch is launching late tonight, we'll work on the car at night when it's not really freaking hot. And go from there. So, yeah, this is up there with one of the crazier rockets that we made. Another, I mean, what's the craziest thing? I don't know. The Nautilus is pretty crazy, if you guys have seen that. The Nautilus is pretty nuts. That was one of the crazier things we built. Where are you? Star Raker was pretty nuts. Doesn't work, but it was pretty nuts. When I play Kerbal, dude, I play Kerbal. We don't screw around. Star Raker does fly, it just doesn't get into space. What made them decide to finally continue with the launch of AX4? Did they reduce the leak rate? They reduced the leak rate when the thing was originally moved. They reduced the leak rate on the ISS see, okay, turn that down. When Axiom was scrubbed a little while back, like a week ago, they were checking the leak rates, dude. They were making sure it doesn't leak anymore. Bro, how? Oh, I don't know, about a month of work here. Month of work in engine design. It has a usable payload bay that includes aero, so you could put whatever in it, and I have an open fairing that works like a payload bay. Whatever you dock inside of that fairing will get occluded. So it actually does, it's a cargo plane that you can actually use to move cargo around. The whole idea was to move the cargo up into space, but the wing shape is amazing, but Kerbal doesn't like this. It makes crazy amounts of drag. It's the drag on Star Raker. That's what got us. That, and it's like 1,200 parts. It takes a long time for that thing to fly up into space. What's the scale you build these at? I build everything at Kerbal scale. Everything is made in KSP scale. KSP scale, and this is from the developers, is about 60% of their real-life counterparts. I have that right from Felipe. That's right from Harvester, the guy that invented Kerbal. I, got to talk to him in my travels. Actually, to be 100% honest, that was from who gave me the original model. It was once removed from Harvester. I think Rover Dude was the one that told me, who's also another KSP dev in C7. I'm friends with them, like most of those original developers. Haven't talked to them in a little while, but they gave me a... So, I was doing a mod for KSP one time. No, it never got published. I don't want to talk about it. And one of the developers gave me a Kerbal model. A T-post Kerbal model, and they said that this is scale. If you set your scale in Maya to this scale, that is the size. That's what we build for. That you can measure the size that way. So I did, and I figured out, and this is from them too, that it's about 60 to 61%. It kind of depends on the artist. Some of them are about 62%, some of them are 61%. So just give or take about 2/3, little under 2/3 of their real life counterparts should get you accurate stuff. So like all the airplanes that we made that I showed you guys last stream, like the F-18, that is built to scale. It is a scale model F-18. That thing is 2/3 scale of a real one. Yeah, I got F-14s, F-15s, F-16s, F-18s, F-4s. What's the K2? Oh, U-2. There you go. What type of guitar do you have? I have a Fender Squier Stratocaster. It's a Squier Strat. This is an Indonesian guitar. But yeah, everything is built to scale. Everything's built to about 60% scale. So if you like put these planes next to each other, they'd be the real life scale of their real life counterparts. What is other crazy things? Project Endurance. The Endurance project is probably one of the crazier ones. That's in Billy Squire? No. Ever built an A10? No. I don't build an A10. I had never built an A10 for a good reason. The reason why I haven't built one is because in order to get an A10 to fly correctly, you need a 30mm depleted uranium Gatling gun that weighs as much as a Volkswagen Beetle to get it to fly right. And we don't have that in KSP. The plane can't fly without the gun in it. Could I fudge it and put like ore up there? Yes, but I'm not going to build an A10 and not have a Gatling gun on it. You know what I mean? Is that another recommendation for playing Realism Overhaul in chat, Phil? Oh, geez. That never happens. Just put a VW Beetle in the nose. Well, I don't have that either. Last, please, for your own health. You have a B2. No. I built a YB49 though, which is kind of like that. All right. Ever built the crawler? I've never built a crawler. I built a piece of it though. Yeah, that's right. I built a piece of it. Hold on. Hey, Adam, what's going on? When is the next car stream? A little later tonight. Okay. Your personal opinion, do you think they'll fly Ship 37 or Ship 39? I think they'll fly 37. I think they're going to rebuild NASA's. What's that doing? You gotta talk with your roommate you're going to stay with in college, and he has a Mazda and is into cars. It's a genius. He used transmission fluid to rejuvenate the apex seals. Tapped it off. Have I built the bone before? I did one a long time ago, Stig. So much so that it's built in an older version of Kerbal, and it's not very good. That's why I never bothered. But they do a very tall adapter for the pad for testing Ship 37 and Ship 38. In the time it would take to engineer that ATOR, you could just rebuild Massey's. I know it's not the cool solution, but it's the right solution. Alright, so this is what we gotta do here. Mic audio sounds like you're transmitting from space instead of Boston. Alright, I'll be back later. Dudes. This isn't gonna work. It's not gonna work. The fans, I have the fan blowing on me and the computers so they don't stay, they don't overheat, and that's clearly too distracting. So it's honestly fine. If it's fine, why'd you say something? Like, I can't, dude, there's not much I can do about this, dude. Like, okay, we'll keep going. It's nasty audio, but you'll still watch. Turn off the compressor. I don't think you want that. All right. Let's get to it. Let's do some deep work here. Any plans to static fire these stages? You gotta build them first, dude. If the problem is the heat, turn it down a bit. Yeah, if I had control over that, it probably wouldn't be as warm as it is now, dude. Oh yeah, let's just do that. Alright, so what could this rocket lift in tons? about 450 tons in one shot. So here, let me show you. This is a Class 1 post-Saturn Apollo here. Let me get the TRS report up. Here we go. So what we're building is the baseline Class 1 vehicle. That's what I want to try to make. It's got 18 F1 engines in the first stage. For reference here, the Saturn V had 5. Okay? And this has 3 M1 engines in the second stage. The M1 rocket motor is a vacuum optimized Hydrolox version of the F1. It makes 32.4 million pounds of thrust between the first and second stages. That's double super heavy. This rocket was going to be no joke. Payload is 980,000 pounds, so about 450, 460 metric tons, somewhere in there, which is insane. Yeah, insane. Good stuff. Feedback: the louder, closer you are, the better it sounds. Okay. Just a 747 at max tow. Yeah. So we're ready to calculate the TWR. I was kind of saving that for later. So right now, I kind of worked on the aft domes and thrust structures for each one of these things. This is not. This is a basic structural design, just so we can figure out engine configuration. Yeah. This rocket's gonna be no joke, man. I am worried about how the first stage is gonna kind of jive together, because the first stage has this skirt on it, and I'm not sure what we're gonna make that out of. Probably a fairing, dudes, but yeah, you gotta be careful with fairings this big. The game use doesn't like fairings this big, but we'll see. Would this have used Saturn V infrastructure? It's called post-Saturn, Andrew, so I highly doubt that. You'd have to carry 400 tons to Leo, or the alternative, 1 GoPro camera to M87. Hey, Red, thanks for the raid, man. So I kind of have my jig set up with the lengths approximated of the stages here. Interstage right there, second stage right there, payload fairing. I did make the PLF. Another tough thing that we're going to have to get right is getting the payload fairing to actually separate correctly. I'm not sure we'll be able to get that to clamshell, guys. Maybe. We'll see. Hey, Tal, what's going on? Merry Christmas from Pandaland. It's not. Christmas. Okay. How's the build going? It's going good, Cake. Getting all this to jive correctly, getting this thrust structure built is going to be a little bit complicated. Have you tested the fairing? I'm sure the explosion will be great. No, I've not. Technically Christmas Eve, today being the 24th and all.
Go at throttle up.
Did I miss something? Red, did I miss something? What? What are you... It's June. It's June, dude. Did I miss something? Red, are you alright? Thanks for the cool post-Apollo report. Reading through the final report for these concepts you posted on the last stream. Cool. Was there a crew variant of this plan? I don't think a crew variant of this would be needed. I think these rockets are entirely for cargo. Half Christmas, exactly 6 months to Christmas Eve. Yeah, okay, I got it. Anyway, thanks for the raid, Red. Appreciate you, buddy. Have you ever played a game called Flight of Novo? No. Alright, so we're going to have to figure out our tank configurations here. This is going to be a little bit difficult to get this right, but I mean, the thrust structure in itself is going to be insane. We really got to start breaking down critical components, dude, because this is kind of a master plan, and we're going to have to break down components into their craft files and then reassemble them all back together, because just building this first stage is going to be insane. That is going to be a lot of kick behind it, and these engines do need to be overclocked a little bit. The other thing I was thinking about is switching to a 6-engine configuration up here, because these engines need to be double clocked. We need to up their thrust output by 200%. And I don't really think mass is going to be an issue here with the amount of kick that these things have. So, we'll see. We're going to need to build the tankage first, figure out the tank configuration, and then what we need to do from there is think how we're going to do this. I'm trying to picture the design in my head. We're going to have to tweak the efficiency too, and you can't well, actually, no, Hellfish, you can't tweak the specific impulse on these with a cal controller. So you have to pick an engine. When you're picking engines for builds like this, you got to pick something that has specific impulse that's closest, and then you can change it around from there. I mean, real life, you could change it by changing what's called an expansion ratio, but we're working with a fixed expansion ratio here. Did you ever make that hinge support part that you made available to download? No, I didn't. Yeah, I didn't do that. I have to work on this piece. I have to tweak the config files. It's not really ready for release. But it is a pretty cool thing. Actually, I should probably, if anybody wants to texture this thing, shoot me a DM on Discord or something. Give you the UVs so you can texture this Kerbal alike and call it a day. I did the top part. That's a hinge strengthening bracket. It basically adds part collision to a hinge to get the joints from bending around, and it strengthens the hinges so they don't bend when you put them under load. Are you gonna make a transporter erector for this? I don't know if we have the part count budget to do something like that hired. How many parts do we have? It's only 85. Alright, let me think about this. I'm trying to think where we should start, because we have a couple of stakeholders. There's a couple of big things. The stakeholder expectations I kind of wrote down already. We need, scale the like, we need about 267 tons payload capacity. Yeah, we need 267 ton payload capacity, 2-stage, and maybe we could boost back and land that first stage. I don't know. The first stage is tall enough to get the correct moment, but the thing about F1 engines, dudes, is that they really don't, F1 engines would not have throttle ability, so landing one of these would be a real big pain in the butt. I'm also worried about aerodynamics, because what I want to do is I want to use fairings to encapsulate the Kerbal fuel tanks, right? I can't make a gigantic 10-meter fuel tank, right? So we have to put a bunch of tanks inside of one, like a Saturn 1B. You have to kind of fudge the design that way. We got to worry about thrust structure. Thrust structure has to be right. If it's not right, we're going to have a bad day. Do you even restart the F1? It uses T-Tab. I'm pretty sure you could restart it if you had multiple T-Tab cartridges in line. I mean, Corsi, I don't even know where we go about putting it up or down. Maybe we'll see. These days, dude. If I finish it, dude, I really want somebody to texture the damn thing. But then again, put it out, call it a day. It's close enough. The top is textured, so. DM'd. Already, Hallingar? Okay, we'll talk later. I mean, in Kerbal, we don't have to worry about it. We could just relight the engine, so. Alright, I'm just trying to think what would be the right spot to start on building this first stage. That's the control node. We don't want that attached there. So, alright, let's go. I'm gonna need my stage control node here. So how I build stuff, guys, is I build it in pieces, and then we can connect it together. So we take something like this piece right here. Hey, Nick, what's going on? And I call this a control node. So this is basically going to be the root part of our first stage assembly, right? And then we will start building the first stage off of this. Just going to make sure we're in line. We are in line. I'm going to build the attachment node for this right on the mark. These dividers right here show the proportions, albeit approximated, of the vehicle. So there we go. So now what I like doing, guys, is, and this, like, I'll be honest with you, they do this, they don't do this exactly in the real life aerospace industry, but it's close. Like, they do stuff like this. They have different things, different jigs to mark different pieces. So, like, I can give you an example. Let's look at, like, the X-59 construction. The X-59 is the low boom supersonic transport test bed. It was built in the Skunk Works. It was built like at Lockheed at Plant 42. So it's built in the same plant that made like the SR-71 and stuff. But see, look, right here. This is when the X-59 was on its assembly jig, right? You see they got a jig for the wing box and the spars, and then they got a jig for the engine section. And then they have a jig piece for the cockpit and the nose and stuff. You see how they build it in pieces and then they connect the sub-assemblies together? We're going to do that, but with stages. They also have swamp coolers. Look at the size of those things. Not going to lie, I just need a fan that big. A swamp cooler isn't going to help me here because we're at 60% humidity, dude. But you see, they build these, their jigs and structures so you could build the vehicle on it. They do. Every airplane's made like that nowadays. Heck, rockets are made that way too. Rockets are made that way going all the way back to the Saturn 1. If we go in here and we look at my rocket research pictures, we go to the Saturn research pictures, take a look. We're just going to blaze through these real quick. That's a Saturn 5. That's how they constructed them in the VAB. That's a 39A. That's a test stand. That's my favorite Chrysler ad. There's Von Braun talking with Walt Disney. Oh, dude, I forgot about that picture. That's cool, man. And it looks like it got a Fairlane behind him. Old Ford Fairlane there. trying to find in here. I have Skylab jig. There's a jig piece for Skylab, right? Fun fact: Skylab had an airlock on it in the docking ring module, and the airlock was actually a door from a Gemini capsule. Not a lot of people know that. So if that looks like a very weird shaped airlock, it's because it is. It's a Gemini capsule door. Giant frame tables. That is ideally what I wanted to make for the Coronet, but I just didn't have the budget for it. Don't worry. Like, maybe down the road we'll do that. You have an engineering background. I'm self-taught when it comes to it, dude. I'm trying to find the jig pieces for the Saturn 1. I have a picture of them sitting in the factory where they were made. I don't know what was going on here, and let's just say that the Apollo engineers were cooking. Just leave it at that. I have no idea what they were doing with that vehicle stage adapter. There's the test stand. That test stand's actually going to be scrapped soon. It's dumb, but whatever. Here we go. There it is. Look at the box jigs. See? That's how they made the Saturn 1. They made it on gigantic box frame jigs. Chrysler did that. Oh, that's so cool. Drag test? I don't know what you're going to test with that, but, you know, I'm not going to ask. Yep, there's the Saturn 1 original test stand at Marshall. It's still there. It's just really not in good condition. It looks like the Titanic. It's rustier than the damn Coronet. Picture of the external tank just kind of stuck in there. I am not sure what this is for. I think that's the 4670 test stand. There's the tab code. That's integration. Here's Michoud in 1967. You could see the jig pieces back there for building the S1C. Those are Saturn V first stages back there. There's 3 of them, just right next to each other. Imagine seeing 3 SLS core stages next to each other. I mean, I'm not gonna lie, I want them to do that, but real. And see all these jig pieces. Those are jig pieces for making rings. This is a piece of tooling right there that is perfectly flat. And you notice how each one of the legs for that proverbial table is a screw jack, so you can level the table perfectly. And then when you build on this thing, it holds everything in place for when you go to weld up the part. See, you can see them, they're welding aluminum rings together with it. They were using a TIG welder, no doubt. Let's see all the jig pieces. This happens in aerospace. They've been doing it for a long time. Also, these pictures are righteous, dude. Look at all the Saturn fins just sitting there. And then the engine covers. I love this picture. I mean, I bet you inside Star Factory probably looks like this it's nowadays. But also 10-meter core, bro. Yeah, but see all the jig pieces? There's a jig for making the interstage over there. See the gray? That is how I make stuff in KSP for the uninitiated. This is how we build. All the stands. I don't really make scaffolding and stuff because I'm working in a 3D space. I don't need the Kerbals don't need to get up on top of the rocket. I mean, unless I want them to, but sorry. This is getting my mind off of the key. That's pretty good. That was a flyback S1C concept. Can you imagine if we did that with this? Later, okay? Make it work first. Make it work first, okay? See all the carts, all the jig pieces. Fun fact, you know how you guys, there's a lot of Starship fans watching the stream. You guys know how, dude, what did SpaceX start with? They started with windbreak, right? They made the windbreak, and then they made high bay 1, right? And they made high bay 2, then they made mega bay 1, mega bay 2. They kept needing bigger and bigger high bays, right? The reason why is because they needed to scale up production and design. The Saturn V was the same way. A lot of people don't know that the first Saturn V stage, and that stage is still around, to be honest with you, that's the SA500 test article. It was the prototype. That's the Mark I for the Saturn V. That's the tank that's the first stage that's at Kennedy Space Center. So if you've ever been to the Saturn V Center, that's a picture of it. But a lot of people don't know it wasn't built at Michoud. It wasn't built with the other Saturn V stages that I just showed you. Michoud wasn't ready yet. The factory was not ready. So the Apollo engineers built it in a hangar at Marshall Space Flight Center. This is a picture of them putting the damn thing together. They put it together in an old hangar because there was nothing big enough. There was no factory big enough to build Saturn first stages. And then they tested it at test stand 4670 at Marshall because there was nothing bigger. The Stennis Space Center wasn't ready yet. Hey, AP. I'm so glad these pictures exist. Me too, man. Me too. So they built them in Huntsville because Huntsville existed. If we go look at Huntsville, I can show you that exact building. I went and found it one day. That was a good deep dive on stream. It's, let me look at it here. That one. There it is. The one that's Saturn V first stage sized. They built it in a pre-existing building, dude. Look at that thing. That was just another building that they were using for ballistic missile research. They built this windbreak-esque thing next to it to put the stupid thing together. At least I think I'm pretty sure that's the right one. It may be that one. It may be this hangar. I'm pretty sure it's that one. Because I don't remember them building a high bay. They had to put it together sideways because there was no place to build a 10-meter rocket core. So they did. They just put it together. I'm pretty sure that's that building right there. I looked it up one time. I forget exactly where it is, but that's what that picture is. You see, they just used the Saturn V transport stools, basically an old school SPMT, to just boop, put them together, dude. Standing on the shoulders of giants, man. And yeah, that first stage is still around. That's the one at Kennedy Space Center. That's SA-500. There's them moving that exact thing onto 4670. Now, here's the reason why I know that's the right building. It's because we followed the path of it one time. So I did like a deep dive on Marshall Space Flight Center one time, right? So there's test stand 4670. That is the first test stand to ever fire a Saturn V first stage, ever. That was the first one. And when they did it, they realized that if we're going to do the Apollo program, if we're going to go to the moon a bunch of times, we need a bigger test stand. So they built bigger test stands. They built the B1, B2 test stand at Stennis, right? Right? So here, it's really obvious that so it's pretty easy to spot that the Saturn V first stage is very big. It's also very heavy, right? Also, can I have one of those? Oh, wait, I do have one of those. Yeah, can I have another one of those? I'll take that Falcon right there. That's fine. Or that F1 that's just sitting out in the rain. Whatever. Anyway, so this is really heavy. The reason why I know that that's the right building is because we traced it. So the Apollo program, to grade the roads correctly, yeah, they put down concrete because concrete can withstand a heavy load. So all the roads are graded to a certain length and width, and we followed the stupid road. See this wide, like 4-lane road? That was designed for moving a Saturn V core. And from here, you can trace it back. I guarantee you we'll find the right building. I may have been wrong, but... Okay, so it goes up here, right? And see the radius corner on the road? That's designed to tow a Saturn V first stage horizontally around. So that means it went this way somewhere, right? Now we got to find another radius that's kind of similar to that, like that one. I doubt it went over here because there's power lines and stuff. See the power lines? I mean, who knows if those were there, but... Then they went up here, and let's find that same diameter road. Dude, you can do this. You guys can do this. You can just trace the path. This is one of my favorite things to do. I'm going to go ahead and guess that that's probably it. See the clearance? clearances for all the pipes. It looks like it could fit a Saturn V first stage through it. See how it's high up off the ground? That ain't normal. Whatever that is going higher than a 2-story building. Saturn V core, right? So that basically leads you right back to this building right here. Or it could have been that one over there with the big NASA logo on it, but I doubt it. But it also could have been. This has a bunch of stage jig parts here. They could have manufactured it a couple different places and then integrated it in that building. To see the wide radius road, that wide road goes right back to this building. See what I mean? You can trace the infrastructure. And it's really easy to figure out how they put this stuff together because of it. Yeah, little deep dive there, or shallow dive on, don't dive in the shallow end, on infrastructure and how they, like, how you set up test stands and stuff. This stuff is super interesting to me. So yeah, if you're like watching on YouTube, guys, you guys haven't seen me do a deep dive like this before. I love this stuff. This is my favorite thing to do. That's the Saturn 1 test stand. It's not in good condition. This picture is actually old. The first Saturn 1B ever assembled was right there. That was the test mule for the Saturn 1B program. They scrapped it because they left it outside for 50 years. Hey, I've been there. There should be a Saturn V standing near the road. The Saturn V is, Adam, it's north of here. It's up here at the Space and Rocket Center. Space and Rocket Center has a dud Saturn V standing upright and a real Saturn V horizontally. Now, you knew that, though, already. Cool thing about U.S. Space and Rocket Center is that they have a backlot with a bunch of parts. From stuff that you might appreciate, like these Saturn V tankage test articles right there. Apollo CSM boilerplate, launch escape system test from the, that was an Orion prototype. There's a Apollo launch escape tower. If you go, Adam, if you go back, looking back here on Google Earth, you can't do it. Can't do it in real life. Dude, they have the backlot area. And look, they got a Saturn 1B fairing sitting back there. See that right there, dude? See that thing right there? You know what that is? It's the flight deck of an airplane. But it's flight dude, I'll be surprised if anybody can guess this if I haven't told you what that was. You know what that is? It's the flight deck of an airplane. It's the flight deck of a bomber. Let me narrow it down a little bit. XB-70? No, Jim, but very close. That's a B-1A flight deck. A real B-1A. Before the program got canceled. That's a B-1A flight deck. JW, B-1B was close. That's a B-1A flight deck. They only made a couple of them, and then Carter canceled the program, and then Reagan later said, nah, let's not do that. There's also an entire Titan II missile sitting back here. That one found its way to, I think that one found its way to the Air Force Missile Museum. There's also a buzz bomb just sitting back there, and I believe that's a Navajo maybe. I forget what missile that is. It's cruise missile, early cruise missile. Dude, they got so much cool stuff sitting back here. Actually, it looks like they cleaned it out. You want to see something cool? Gone. Oh, it's gone. Thank God. If you go back in the date imagery here, there's a Titan stage. There's a Titan first stage, a Titan II first stage sitting here. And that Titan II stage was the only Titan stage ever to be recovered. That's right. During the Gemini program, they launched a Gemini mission. I forget which one. First stage actually came down and it landed intact. It's really light. So the tankage actually landed in the water and it was fine. And they pulled the tankage out. It's the only Titan ever recovered. Gemini 5, thank you. What year is this view? It's not giving me a date, dude. But that Titan stage was sitting here, and that one is in the Space and Missile Museum too. Now, don't go trespassing in the museums, up in the museum's grill. Don't do that. Don't do that. Don't do that. There's Jupiter, Redstone, Juno, I think, too. the U.S. Space and Rocket Center has been going through a lot of renovations lately. They actually just completed a big renovation because the museum wasn't doing so well. And then they got new investment, and now it's doing a lot better. Crazy thing here. This is the stuff that is on display. So see that? That's the underwater Skylab training equipment. You want to hear something crazy? You want to know how tapped the freaking Apollo engineers were? This was for underwater training. So this is they put this in the water in a pool like a neutral buoyancy lab before the neutral buoyancy lab existed. Then they used that for conducting EVAs at Skylab during the Skylab 2, 3, and 4 missions. Want to know how cooked they are? That's an actual Saturn V third stage. That's an S4B. That's a real one. They took the motor off and said, all right, take the motor off, take the electronics off, attach a Skylab docking to it, put it in the water so we can practice. Pretty crazy, right? That's a real Saturn V third stage. That was the Saturn V third stage for the that was the Saturn V third stage, I think, for the Apollo 19 mission. I think. I'm guessing. It's for 18, 19, or 20. It was one of them. There's also an Atlas missile right there and a Chinook, and yeah, U.S. Space and Rocket Center has a lot of cool stuff, man. That's a real Saturn on a real Saturn 1 launch mount, which is pretty sweet. And then over here, they just completed refurbishing Pathfinder, which was the fitment testing article, the pathfinding test article for the shuttle program. Yeah, that's a real external tank, and those are they're real ASRBs. That's what they're called. That's a test article external tank, and those are a concept for advanced SRBs that they did that NASA was working on in the 80s. It's called an ASRB. Pretty cool, huh? That shuttle has an actual serial number. It's a shuttle. It is a shuttle by definition. It has a serial number from the factory.
Discovery, go at throttle up.
Now, it's debated. Some people are like, nah, it's not. But yeah, see, they're working on Pathfinder there. In reality, Pathfinder really has no resemblance to the shuttle, with the exception of the crane hoisting points, because that's what they used Pathfinder for. OV098, they used it for load testing. So like that was used to test the mate-demate device, right? It was used to test the shuttle integration pieces. That's at Huntsville, or that's at Marshall. That's the SA500, or the Saturn V dynamic test stand. It has a serial number from Rockwell. It's a real shuttle, but it's got a Bondo and fiberglass shell on top of it. See? So it is a real shuttle, but it isn't a real shuttle. But it is a real shuttle. It can attach to an external tank just like a regular shuttle can. Pretty cool, huh? But see, look, throughout all this, jigs and templates everywhere. That was a little bit of a deep dive from your boy. I build stuff in KSP like that. I make templates and I make test articles and stuff. So that's what we're going to have to do. Building out a rocket as big as this one, this post-Apollo-Saturn thing, we're going to have to dude, we have to. We got to build it that way. So I'm not just going to start at the top here and then just build our way back. I'll start at the top of every stage, and then later we'll combine this all into a craft file and make the launch vehicle file. Okay? Test article in orange. In what context? Hey, Kawota, 36-month resub. Thank you. I wish some of you guys were here when I did my actual shuttle program, because I went through all of this. It's crazy how all this stuff is just laying there. AP space. I was pissed that the Space and Rocket Center let all that stuff just sit outside. Two things. One, it's in Alabama. It's not going to rust. That part of Alabama is it's a temperate climate. It doesn't snow there. So they'll be fine outside. Just gets a little bit humid. The aluminum might corrode a little bit, but it's not that big of a deal. Second of all, the museum got funding after the pandemic. I forget where it got it from. I knew a guy that worked there for a little while. They got funding and they actually cleaned up all that stuff and fixed it, which is pretty cool. Yeah, so it's not just lying outside decrepit anymore. They like fixed everything and put it all on display, which is super cool. Check out the U.S. Base and Rocket Center in Huntsville. It's amazing. It's one of the best. It's one of the best space flight museums in the country. The only thing I think would be better would be like Kennedy Space Center visitors, or Johnson Space Center in Houston. So, yeah. E.G., did you see the ULA launch? She leapt off the pad. Yeah, Grass. I didn't watch KAO2 live. I fell asleep. But yeah, Atlas 551 always packs a little bit of a punch. I mean, you got five SRBs in the first stage. With that RD-180 just churning away. That's a lot of power for a rocket that size. But that's awesome, man. Oh, I think it was Rares. I think you asked if I ever built a crawler. I built a crawler, but I built Derek. Does that help? There's Derek there. Destin is from that area. Adam, don't quote me on this. I think Destin works in the aerospace industry. I'm pretty sure he does. He might work at Marshall. I have no idea, dude. There's a huge aerospace presence in Huntsville. Yeah, it's not just NASA. ULA is there. Blue Origin is there. United is there. There's tons. There's a big aerospace presence in there. Jared Isaacman gave them a ton of money for renovating Space Camp and just normal operations. Was it Jared Isaacman? Yeah, I think you're right, actually. I think it was. So I haven't built a crawler, but I have built part of a crawler. This is a tracked vehicle in stock KSP. Tracked vehicle. Complete with belt tensioner. Oh yeah, it works. I had to read a lot about how tracked vehicles work to get this thing to work, but it works. I'm from right around the corner from the Space Center. It was the reason behind me wanting to work in the aerospace industry. Dalton, yeah, it's awesome, dude. Just wanted to tell you, good luck. We're all counting on it. How do you get those vehicles to not crack in themselves? Same vessel collision, guy. Same vessel collision is what does it with me. See, same vessel collision between the idler. These are called idlers in a tracked vehicle. I'm using circular grip pads as an idler, and I'm using regular just grip pads as a tread. They're connected to each other on hinges. In terms of how I don't get this thing to crack in itself, well, the track goes all the way around and it's keyed. It's keyed right there, and then there's a strut. The strut is acting as my key to hold the thing together. And then it's connected to a reciprocating dingle arm right there that keeps the track in line. Here, I'll show you. It's easier to just show you. This is one vehicle. Almost knocked over the Super Heavy mock-up. Come on, Super Heavy. Just spinning my joystick. Ouch. For KSP. So, we got to tension the tracks first. But you don't want to get too much tension, and then there you go. Get the drive wheels working. So, the key joint, if you look, the key joint there is attached to two struts that have no power. And as they rotate around, the struts, these hydraulics, there's no power behind them. They're just kind of free floating. They move around with the track, with the key joint right there. See? It moves around with it. And it's connected with a rotor that has no power, right? And the rotor is what rotates the root part of the track around the idlers and the drive wheels. Crazy thing about it is that we programmed a cal controller to get the thing to steer. I can turn it if we really want to. It's a little finicky. Sometimes you jam up tracks, but you can get the vehicle to turn. So I have a cal controller that modulates the throttle between the left drive wheel and the right drive wheel. So if you turn left, it'll shut the left track off, or reverse it, and it'll turn the right one forward. It'll keep the right one going. See? and the vehicle will turn. It just doesn't turn very well. Like I said, I never really worked out the kinks of it. This was just a proof of concept to see if you could build a tracked vehicle. It's totally doable. You can build a tracked vehicle in KSP, but like tracked vehicles in real life, it really doesn't like going too incredibly fast. You're gonna throw a tread if you try to turn at high speed, which is what happens in real life. But yeah, have I built a crawler in a tracked vehicle? Yeah, absolutely. Dude, you guys don't know. I put 20,000 for Twitch. You guys know this already, but like for the people over on YouTube, you don't know me. I played Kerbal pretty much every day for about like 10 years straight. Yeah, that's all I played. That's all I streamed. We've built all of this. Isn't even half of it. I have everything, like anything and everything. The only thing I really didn't get into is building weapon systems. I don't build weapons because, I mean, I think I've done it once or twice when I was really annoyed, and I made like a Scud launcher or something. It was pretty cool, but yeah, we built everything from Tesla semis to tracked vehicles, recovery vehicles, jeeps, trucks, cars, planes, cargo planes, helicopters, everything. Shuttle missions. We built space stations with shuttle. We've gone to the moon a bajillion times. Like, I built a ramp truck for getting people out of the shuttle after my shuttle landed. Built a little pickup truck. You have a hot air balloon. You can't really make that in KSP without mods. This was all done in stock KSP with the 2 DLCs, dude. Helios is working with collectives using homemade gears. Yeah, it's possible. You can do that in this game. You got to be careful about spinning the gears too fast, though, or else it doesn't. The game gets upset with you. Oh, they're those kind of gears, Owens. Oh, those. Yeah. Mm-hmm. Anyway, let's get back to working on Prometheus. That was a little bit of a sidetrack there to like an intro to how I build stuff. I build stuff like they build stuff in real life. So right now we're going to work on our first stage here. We're going to get a prototype and go from there. So now, how are we going to make this work? What I would want to do is build a centralized axis here. How Kerbal really likes to do this is there's this thing called hierarchy. And you guys probably heard me drone on and on about it for a long time. Hierarchy in Kerbal is really how you prevent the Kraken from coming after you. Long story short, Kerbal really kind of favors a single stack of building. Like, you want to build a centralized like load carrying column for your rocket, and then build kind of everything else around that. That's what it really likes. It doesn't like transferring load in any other direction. That, and there's this other thing that you can, I'm trying to remember my own building rules. You can really make things super strong the least amount of connections you have between like the top of a stage and the bottom of a stage. So let me give you guys an example. If you're a Kerbal player and you want a tank, you need a lot of tankage, right? You're not going to do this. You're not going to do that. Any Kerbal players here, why wouldn't you do this? Because this is going to turn into a wet noodle when you go to fly it. It's going to just flap all over the place, right? You wouldn't do that. You'd use this instead, right? You'd use that. Why would you use that? Well, that doesn't bend, right? So when you're building a big rocket like this, or any type of thing that's not just stacking tanks on tanks in KSP, you want a type of hierarchy that favors the least amount. So like how you build it, the least amount of connections between like interfacing points. So I would want the least amount of connections between wherever this connects to the second stage and the bottom of this, the engines. Why? Because the engines are what's pushing up on the vehicle. You want a nice, clearly defined load pathway, and you don't want your rocket to wobble around. So here's what I do. Let's think about this for a second. How are we going to do this? Well, in our this tab, in our post-Saturn V class baseline vehicle, the first stage has a kind of conic interstage right there. See that? We have a conic interstage that picks up on the aft skirt of our second stage. Okay? We didn't model the aft skirt of our second stage in KSP, but we do have the size of it. We have the diameter already indicated by this aft dome that we have for the second stage. Now the aft dome, I have another set of control nodes for. See? This right here, see those struts are showing the outside of the aft dome. Now, the aft dome of this vehicle, as we basically just said, hold on a second. The aft dome of the vehicle is not, it's tapered in because it's supposed to be a common dome, right? That's just a better way to set up your fairing. But second stage, we know that the second stage aft skirt, which we're also going to have to make out of a fairing, needs to go all the way back here. It needs to go back to this point right there. So let's see these struts up here. I'm using as rulers to mark the sections, right? So there you go. That's going to mark it pretty well. I might edit this fairing down a little bit because it's not really picking up on the right spot that I want. We need to pick up on the inner diameter of the strut as previously noted in part 1. So the innermost part of the strut right there, the bottom of that strut rail is basically that's where it needs to be. It doesn't need to be like it was clipping before. I want to be able to see the strut. But the reason why I do this is because you can build fairings and you can use that as a straight line to measure things, right? You can use it as a straight line to measure things and you don't need to worry about clipping into anything. So that's why I use these markers. So if these markers are going all the way back to here, right, that gives me a point to end my taper, my conic interstage here, right? So here's what we do. Let's get, I think I was using 375s here. I was using 375 fairings for this. It might be better to use a 5-meter fairing. Oh my god, he's making Nova. What's up, Ryan? I'm not making Nova exactly. This is post Nova. We found a NASA technical report, dude, that talks about, and this is from like the first AIA meeting in like 1964. They were talking about what they'd need after they wring all the use out of the Saturn family of rockets. So this is not Nova. It's post-Nova. And, you know, like, everyone's like, they're not, you know, EJ, they were never going to make... Dude, this uses M1s and Aerojet Rocketdyne. Actually, it was just Aerojet at the time. Aerojet General actually started testing M1 engines. Now, Ryan, I don't know if you know what an M1 engine is. An M1 engine is a vacuum-optimized Hydrolox F1 engine. 1.5 million pounds of thrust. From a Hydrolox vacuum-optimized F1. The motor is 3 stories tall. Or, to speak in more modern rocketology terms, it's 2 vectors tall. Vacuum Raptors, they're pretty big, right? It's 2 of them. 2 of them stacked on top of each other. That's how big this sucker was. 18 F1s. How much thrust do you want? Yes, that's how much I want. So, as you can see, we do not want our rocket bending here. We Do not want a bendy rocket. Bendy rocket, bad. Especially when we're going to be putting out the Kerbal equivalent of 32.4 million pounds of thrust. That's 30 meganewtons for the metric people. 30,000 kilonewtons of thrust. That's... No. Yeah, no, that's more than that. It's 60 meganewtons. No, it's more than that. It's 72 meganewtons. Sorry, I was doing the calculations wrong. Yeah, this thing had 18 F1s have double the amount of thrust of a super heavy. That's probably a better way to explain that. So, once again, this thing needs to be strong because that is what's pushing on the bottom. It needs to be very, very, very strong. So, we're going to have to figure out the least amount of connections that we need to go from here to basically the back of this thing. Now, if you look, I do have a control node back here that I was using for testing and mock-up to kind of get our engine configurations here. This is just a mock-up. It's attached to a ruler control node. So there's a control node right there that's controlling the rulers for the diameter of my first stage. We scaled all the numbers already for KSP. And there's our engine, kind of a mock-up of our engine configuration. Now we need to design the damn tankage for this thing. So this part, that control node is going to kind of be junk. And this piece is just a mock-up. That's our pathfinder, so to speak. Right? So now what we got to do is I have to get these control nodes, I have to get them as forward as possible up here so we can build the tapered section for this. So there's my stage 1 control node. What I'm going to do, I have put some flags on it. I have a flag pack that's just that just has numbers and letters. You can get this in the Twitch chat if you type in !point flags. I'm just using this to denote what this control node is. So S1CN, stage 1 control node. Right? That's all we need right there. All right, so now, what's our first part of the control node? Well, the first piece is making a tapered section, conic interstage. That's where we're going to start, because that's the top of this stage. See, I'm going to have to move this. We're going to have to move this out of the way. It won't let me place this correctly if we don't do this exactly right. It's all right. I'm going to take another ruler here. Right? And what we're going to do with this ruler is we're going to bring it all the way up here. And then I'm going to bring her back here, and I'm going to point that ruler at the spot where I need my conic interstage adapter to end. Right there. See what I'm talking about? I just angled it down, and I just basically drew a diagonal right here. And we can set this control node that needs to clip right there. Okay. So see, that is intersecting right at the lower diameter of the strut, right where the aft section gets flat. Right? Now, this is just a mock-up. We're going to have to get rid of it. So I'm going to make a new one here called Prometheus Revision 1.
I'm in space.
Right? Save that. Raptor gifted a sub to OnlyFans. Nice. And what we can do here is mock-up control node needs to be moved. Or I need to move the mock-up piece out of the way. But I want to remember its position here. So what I will do is on my stage 2 ruler controls right here, I will take this piece we will find in 3D space where the top of the mock-up ends up. So I'm just going to take an absolute a ruler and just set it and move that in kind of like a caliper. That should remember our position for the mock-up, because what I'm going to need to do here, guys, is we'll move it. We got to move it out of the way. So I'm going to take this and we'll slide this forward on its jig like that. Now I know where that piece needs to be back in the right position. But because I moved it and the engine's out of the way, I know exactly where our tapered stage needs to be. The conic interstage. So we're starting by building that piece right there. See that guy? That's where we're starting. Because we're starting at the top of the first stage and then we're working our way back. Then, you guessed it, we start at the top of the second stage and then we work our way back. And then, once I have all this put together, I take it all off of the jigs on the master control nodes. We pull them off the control nodes and then we put them all together in a separate craft file to make a flight vehicle. I follow the integration and testing, or the integration pathways that basically they do in real life. The whole rocket isn't made in one shot. SpaceX makes Falcon 9s over here, and they make Falcon 9 second stages over here, and they make Falcon 9 first stages over here. Right? Not everything is made on, you don't make the entire stack. That's how I make vehicles. I make subcomponents. The reason why we make subcomponents, and I don't have it in one big old master craft file, except for this one. This one is going to be our build file, right? The reason why I don't do that is because, one, I don't need it to launch with all the tooling and jig and rulers, right? We don't need that. That's not going to go very far if it has a huge floppy I-beam attached to the side of the rocket. That's not going to work very well. And two, engineering out the individual subcomponents makes it a lot easier to diagnose and troubleshoot if something goes wrong. If something breaks, all right, oh, we've narrowed it down to a thrust structure problem in the first stage. Now I don't need to go and modify an entire damn craft file. We go into the first stage craft file and we have it isolated so we can test it. That makes sense? In a very similar manner, like you have SpaceX at McGregor has a first stage test stand and a second stage test stand, right? There's two different test stands. So keeping your sub-assemblies out, like keeping everything squared away from each other and then attaching it all together at the end, that's the way I like building. You don't have to build this way, but I like doing it this way. It makes it much easier to troubleshoot. And believe me, this thing's gonna blow up. I will tell you, this thing will explode more than once. It will pop at some point. We'll see it explode, either on the test stand, Ship 36, or in flight. Ideally, it would be nice to get that explosion done during testing, but I'll talk more about that in a second. What is the diameter of the first stage? In Kerbal or in real life, Henrys? No, I mentioned, the reason why I mentioned Ship 36 isn't as a derogatory thing. Imagine if SpaceX skipped the testing and that faulty COPV was on a full stack. That would have ended very poorly, and now you're out of pad. Right? I mentioned that as there's a really good reason why they use test stands. And that's not just SpaceX, everyone does. I just showed you some of NASA's from the Apollo program. There's a really good reason for that. Because it's better to find those problems then rather than when you're testing. Now, don't get me wrong, SpaceX is a little bit more laissez-faire about sending it. They'll be like, all right, send it, right? In real life, 65.5 on the first stage diameter and 60 feet on the second stage diameter. That is 18 and a half meters and then 18 and a half and then what's 18 and a half plus it's 5 feet. So 5 feet is 1.5 meters. So 18 and a half and 20 meter, basically. I think I actually wrote it down. Hold on. I wrote it down, but it's in standard. So 60-foot diameter second stage, which is, yeah, that's 18.5, give or take. And then 65.5 first stage is, in real life, it would have been, yeah, between 19 and 20 meters. It wasn't a whole number. 18.2 and 19.9, there you go. And then I scaled those numbers into KSP to get a Kerbal equivalent of this vehicle. Okay, Creeper. All right, so we have our stage 1 control node. So, I don't know. Should we use a 5-meter fairing or a 375? I'm inclined to use 375-meter fairings, and this is a little bit more of advanced Kerbal building here. I'm inclined to use 375 because I find with 3.75 fairings you have much higher fidelity control of the fairing shape. I don't know what the developers did when they made these fairings, but like when you build this, if you hit C and turn off snap, you can make some very, very well defined shapes that are very sharp. Right? Like if we look at this fairing shape, the edge doesn't it bonks a little bit right there. See how it kind of goes in, then it goes out? That's just how the fairing script was written is the right word there. If you try to do the same thing with a 5-meter fairing, I find that it doesn't like it as much. It's much more likely to taper. Actually, the 5-meter fairing is tapering less than the 375. Interesting. All right. We're going to need to test that because I may have been remembering it completely backwards, but we're going to need to test it. So, let me just move this back so we can find a place for this. I'm going to move the mock-up back into position here, just temporarily. That's where that needs to go, and I want to make sure we have the clearance here. I always leave a little bit of space between my upper stage engines and the bottom of the first stage, or the top of the first stage. This is, yeah. Give me 1 second. I'm looking at something. There's that skirt right there. Some of my proportions might be a little bit incorrect. I do believe this piece needs to go back. Because we need the intersection piece right. I need a vertical ruler. I'm going to get another ruler here. I'm going to attach it to my marker for the interstage piece. Actually, you know what? It'd be better to have that on a separate node. So let me just attach this to my second stage ruler control node right there. And we need to take this ruler, turn it 90 degrees upright. And we got to take the end of it, and we got to make sure that it's lining up with our proportion piece. Right? So that needs to be right around there. So that's where the aft skirt on our second stage will end, right? And then I'm going to need another one here. I'm going to put this on my first stage control node. My first stage ruler control node. No. Sometimes if it's too far away, the strut doesn't run. Struts don't run, man. All right, watch. So if I make a vertical mark here, right, and we move this thing all the way down like that, we kind of move it into the same spot so I know. Move that back, and we move it into position that lines up with my proportion nodes, right? The diagonal strut, that should give us the shape for the diagonal. So this needs to go back like that. Now, it does look like we did get my diagonal was actually pretty dang close. It was just in the wrong spot. That angle does look right, but we might need to move it down because remember, it needs to be at the bottom here, and then it needs to be a diagonal to the bottom of that strut. What I'm going to do to get a little bit better control is I'm going to shorten up this ruler. If Strip 36 happened at the pad, they wouldn't have had to dig a new flame trench. Yeah, you're not wrong. Move that up and then set it to absolute and then move it back just a little bit. There we go. There's the taper. That is it to a T. So now we'll make the actual shape for it. Now, take a look. We're gonna go to build this fairing, but when you build it, you can't like go. You could go straight up like this and then try to build it. There's a couple of reasons why you don't want to do that. Making a fairing that's basically essentially just a wall like that is really, Kerbal Aerodynamics does not like that. Let me put it that way. So I always make the fairing taper forward a little bit. And then we go to we match, make sure we have angle snap off. We match the diameter there, and it did leave a little bit of a hump. Hold on. So now, if we left alt left mouse button, terminate it. There we go. There's our interstage piece. Now, sometimes when you make this, I don't like that. It's awfully steep. Sad. Interesting way to use struts. This is what happens when you spend way too much time in the SPH, man. That's what I do. They're good for marking templates and making straight lines that you can draw. And Astro Knucklehead, I saw you plug my rant at Starbase Live. Thank you. Not rant, my deep dive. Thank you. I appreciate it. Oh, I have that chat up. Don't you worry. Now, see, I'm not sure I like how that thing is aerodynamically going to work. The game's going to have some trouble understanding this aerodynamic shape. But there are ways around that. Let's build it. We'll build the entire shell of the first stage first, and then we'll check it. Alright, so we got our first piece right there. Now let's think about this. Actually, I'm not. The separation mechanism for this actually shouldn't be too bad. What I forgot to do is put the attachment mechanism on here. So I'm going to take that stage off for a second, and we need to put a way to be able to couple it up to our second stage. That'll work. We just move this back here. Attach the fairing. Now let's make sure, I think because I offset the position of that fairing with the docking port, that it's not in the right spot anymore. So now we gotta move it back into the right spot. There we go, perfect. Excellent. Cool, good. All right, Note that I used the docking port there. Note that I used a small docking port there, not anything else. I used the small docking, not a decoupler, not a stack separator, not a bigger docking port, but the smallest docking port and a docking port at that. It's not a separator. You auto strut that, mess with its docking attachment port, switch it to nothing, and go from there. That needs to be set to grandparent. Go there. Now take this fairing, make sure it's not staged. This fairing should never deploy, it's just an interstage. That fairing is acting as an interstage piece right now. So, truss structure is off. Set fairing stage off. There we go. How is the stage separation going to work in that thing? It looks like in the actual design they're using quite large ullage motors. We'll use ullage motors. That's why I'm not using a stack separator. To be totally honest with you, Simon, there's no decoupler in the game that's going to have enough stack separation force to move that stage away from the first stage. So either we hot stage it like Starship, which means our first stage would pretty much blow up, or we use an ullage separation system. Actually, I'm not even sure if those are ullage motors, to be honest with you. Dude, they might just be SRBs that they attach to the side. That was how Apollo did a lot of things. That's how Apollo did a lot of stage separation, like the S1, S2 stage separator on the Saturn V. It's just little rocket engines attached to the side to get them to move apart from each other, because there's no spring. There's no spring that's going to be strong enough to spring these things away. That's how a decoupler usually works. It's just spring loaded. But problem is, you'd need a spring that has enough force to push away. Its launch weight is 25.2 million pounds. Let's just say that second stage is probably like 10 million. Like, just a nice round number. You'd need a spring that has 10 million pounds of force. No, it's easier to make a rocket engine have 10 million pounds of force than a spring. The light's turning into a strobe light, dudes. The studio light was flickering. So, the interesting thing about this is that it seems to have some type of ullage separation for the top. I'm not sure what those are up there, nor am I sure what those are either. We might have to read more into it. Anyway, so we have our interstage piece. I forget how to make hollow fairings in this game, to be honest with you. I don't know if we'll be able to, like, have this fairing clip. Are you going to use the SRBs? We have plenty of small rocket motors in this game to be able to use as ullage engines, sure. This is an expendable vehicle. So what we can do is just do that. Obviously, they'll put a nose cone on it, right? And we'll use those to separate the small SRBs. Each one of those has 12.5 kilonewtons of thrust. That should be enough to get it to move. Now, I gotta test that this fairing is hollow somehow, dudes. Because obviously when we go to separate, sometimes the fairings auto strut. They phantom strut stuff that's sitting inside of the fairing. That happened because when they first put fairings in the games, people didn't know how to secure the payload correctly, and the payloads were flopping in and out of the fairing, and it made the game very confused. So the developers added kind of a auto strut thing. I don't want the auto strut, the phantom strutting, to be happening here. The reason why is because, well, the engines have to separate out of here, and if they're locked to this fairing, we'll go to separate, and the auto strut will try to stay strutted, right? And they'll basically, the game will freak out. We have to make sure that this fairing is hollow. So this is the Prometheus interstage test. We'll make a new craft file, and we'll call it Prometheus interstage testing. We just have to verify that this fairing is hollow. So this is the Prometheus rocket Onic ISA interstage adapter test. Alright, we did this test on 6/2/24/25. So we're going to save a new file. And now what we're going to do is reroute to our stage 1 master control node. We're going to reroute to the S1 master control node and then delete the original root part. So now we just have that exact interstage that we just made. No questions. So now we got to make sure that this thing, we got to verify that this thing is hollow. How do you do that? Well, a good way to do it is have a Kerbal walk around in it. That's a nice way to get it done. Hey, big body. What's going on, man? That's just so the fairing doesn't move around. All right, so let's put this out. Let's get Jeb out here. Don't know if you knew your mic is glitching. Slackster, what do you think? Do you think I knew that? Bingo. She nice and hollow. Guys, in order to not completely fry in here, okay, so we verified that the interstage is good. It's hollow. In order to not completely fry in here, I have all the fans blowing, moving the air around, and one of them's blowing on the mic, and it's screwing with the compressor. Breaking news, a crane collapsed at Massey's. Lab Padres footage. That one. That's got a lot of deflection. Empty beer can. What's up, man? Thanks for that Prime sub. Welcome to Mission Control. Your go with throttle up. That's not good. That's not good. That's probably gonna delay more than anything, dude. You gotta, yeah, because you lost a crane, and hopefully no people got hurt. People first, though. Crane second. What's not good? Oh, can't see me. I'll play the footage from Lab Padre. Zach just posted this a second ago. Take a look. Watch that crane right there. It's very subtle. Hope nobody was hurt. Yeah, me too, man. That's crane lifting stuff. Serious business, dude. You really can't screw around with that. Dude, that's what I'm like, get the crane, dude, screw that. Get the bulldozer out. Push it around. This lifting stuff is just bulldoze it all. That's why I was saying, like, we're talking about Massey's before, right? I was saying, like, just where's the interstage? When I was talking about that before, I was saying just bulldoze the whole damn thing. It's not going to take long to rebuild the whole thing. But what they were trying to do is lift most likely damaged stuff around. And the thing about lifting like something that's damaged, guys, is when you lift it, like if you're lifting Starship parts, for instance, is that they're not like structurally rigid. So like if you pick up a piece of Starship, if it's blowing around in the wind, it's gonna flap. It's, you know, if it's not like pressurized or anything, like you pick up a piece of the tank, it's gonna flap around in the wind. It's gonna have the structural stability of tinfoil. And if the thing just starts swinging back and forth, it's gonna knock a crane over. And that's why, like with debris removal, I was just like, dude, just take the dang thing and bulldoze the whole damn site. There we go. So I took the interstage back from, I merged it with the craft file. We took it back. We put it back in the Prometheus craft file. We verified that this interstage does work. I seem to be missing some control nodes here. They were our vertical control nodes. I don't think I saved the original Prometheus craft file. Anyway. Well. Oh, the R1 file. That's right. Get rid of this. This is... Don't save anything. Yes. Thank you, Snake. Yeah, revision 1. I save a new craft file anytime we make a big change. You can account for the wind, though. It's not hard to be safe with that. I mean... Sparky, that's an interesting thing to say, considering it doesn't look like they did any of those things. You know? I mean, it couldn't have been wind. Maybe the load shifted. It happens. It could be a bunch of different things, dude. Okay, so now we've verified that that's nice. That this thing is in fact hollow. Have you ever thought about doing RP1 streams? No, I haven't ever. It's never been recommended to me before ever. Block. Like I don't get recommended that like every 5 minutes. Nah, it's never happened. Yeah, it pretty much once a Kerbal stream, somebody suggests it. I really don't want to. Maybe sometime in the future. I just want to play Kerbal the way I want to play Kerbal, dude. Could the crane have been damaged during the fire? I don't know if those telescoping cranes were there, dude. Maybe. Everything, dude. Try to keep this freaking place cool. It doesn't want to, but whatever, I can deal. Once again, I'm just worried about breaking something. Alright, anyway, let's keep going. So, alright, we got our interstage set up, and now I've decided to go with 5-meter fairings. I'm going to make all of this out of 5-meter fairings, because 375s have a kind of a different like wall thickness, I guess is the right way to say it. It's a different wall thickness, and having fairings with different wall thickness kind of jive with each other doesn't really work too well. So this back tank piece and this piece will stay as just guides for our diameters here. So now the next thing we need to do is build out we got to build out the tank wall of the first stage. Move this back here. Let me just verify that this is diameter. Yeah, it's not. Okay, cool. So I've already found mistakes that I'm making. Now that's the correct diameter, which means it would match up with this. But once again, that's a 375 fairing. We're just using that for mock-up purposes. Same with this one. That's just a visualization. That's nowhere near the final design. So now we have another decision to make here. The decision is, how are we going to carry the load from the thrust from 18 well, technically there's 19 in my design. 19 because Kerbalize. 19 of these bad boys all the way up there. Now keep in mind, we do need to employ cow overclocking. So to get the scaled thrust output of this, it would, in using Mastodon engines, we would need to pretty much have 36 F1s in the first stage, or not F1s, Mastodons. To equate out to 18, we'd need 36 of those, but we'll employ cal overclocking, I think. In Kerbal, you can overclock the thrust output on these things with a cal controller. I'll show more how to do that later. But yeah, we'd have to double the scale of these motors. So I think I wrote it down. First stage engines need to make 300% thrust. They need to make 300%. Okay. Denny, I have fans blowing around, dude, to try and keep this place cool. It's not working. There's only so much I can do when it's 95 Fahrenheit outside. That's well above 30°C for everybody else. That's in my, well, it's 86 or about 30°C in my office right now. There's only so much I can do to move everything around. The weird audio that you're hearing is the fan blowing against my mic. It's actually not causing any buffeting, interestingly enough. It's actually moving the mic back and forth. Like it's like physically blowing the mic. So, yeah, I kind of can't do much more with it, dude. But at least given the time circumstances, I'll figure out a way to do it. It's not going to stay hot forever. So I'm not too incredibly worried about it. Like, the heat isn't bothering me, guys. I'm fine. It's just the, I'm worried about it. I'm worried about breaking the computer. Bucket of ice time. Okay. No, I don't want to talk about it. I don't want to talk about it. I want to work on this, dude. All right. So what I'm really thinking about now, dudes, is what are we going to... How are we going to carry the load? At least from whatever I make the engine structure. How are we going to carry that? That's going to be a little bit difficult to get that right. If we take this and we actually turn them around, them this way like that, and then go here, this, I can move my stage 1 ruler control node. Oh, the ruler control node is attached back there. Walls. I should really put that on my master control node, but it's okay. That's as far back as those will go. I'm thinking. Hey.
What are you doing?
Pod, keep that door closed. What's up, Ring?
Wait a second.
Sure. I'll be right back, 1 second. Okie dokie, I'm back. All right, so depends on how you construct it. If you carry it through your tank clusters, it could work unless you end up with space at the top of the stage. We should try our order windows today. Okay, I think I know what I want to do. So, let's go back and look at the file. So I'm thinking we have a center node, like what we always do, surrounded by tanks. Tanks attached at the top, right? Go down so we can spread the load 4 times over, right? Because making it go up a single, like, centerpiece might not be the smartest decision. But maybe we should go with no centerpiece at all. Grandparent strut right to the fairings. That's not a bad idea. If that's the case, I'd probably want to do an intermediate fairing. So use 2 fairings to make this shape. How much can the fairings support? They're not going to be supporting anything. The fairings are going to be the outer shape. It's the fairing plate, and the fairing plate's pretty damn strong. Hey, Scotty Park.
Discovery, go and throttle up.
Welcome to Mission Control. Here we go, throttle. Thanks, man. Okay. So I'm thinking an intermediate fairing here, and then aft fairing here to make the aft tank wall. And then for the tapered thrust structure here, what we can do is have another fairing that's not in the main line here. It'll be attached to one of the fairing interstage nodes facing downwards. This damn light keeps flickering. I hope I'm not gonna fix them. Stop it! Light sucks. No worries, dude. Been watching over on YouTube. All right, on, man. Thank you. I'm worried about the aerodynamics of a downward fairing. We're gonna have to test the aero of this stage here. That should be fun when we go to do that. The downward taper. Yeah. So we have conic interstage, downward fairing, the aft fairing section. Thrust structure will be attached to the aft fairing section with struts to the tankage, just like how this is set up. That should work. And then an interstage node strutted with the taper downward. That should work just fine. You could even make the downward taper piece part of the engine section. That's actually not a bad idea. Yeah, okay. All right, I think I got a good idea how I want to do this. All right, so get another 5-meter fairing. And we need it to be an intermediate piece, right? There. I'm going to have to move the mock-up piece out of the way, guys. So what we will do, just like we did before, is make a vertical. That in here. Hopefully we can move that far enough back. Yes, we can. Excellent. Sweet. All right, that's the marker for our mock-up piece. We're just going to move that piece out of the way. Yeah, just just move it out of the way. Yeah, yes, master.
Discovery, go at throttle up.
Okay. Now, where's the aft tank section of this? Aft tank sections in plumbing is after the tapered piece. It's hard to say exactly where that ends up. Maybe 40 feet from the back. So 40 divided by 3.3 times 0.6, 7 meters off the back of this thing is where the taper should start. Now keep in mind, I rounded those numbers. It was 7.2. So let's get our measurement out here. So that's 3, 6. Actually, it's right about where that piece is. That's actually really good. Yeah. Okay. Okay, so now what I'm going to do is I'm going to get some I-beams out. I-beams are, I use them for rulers a lot, or measuring. They're not used like the strut rulers. These are good at denoting length because one of these I-beams, if you clip the edge, one of them is 3 meters long, and if you clip, now you got a perfect 6 meters, right? So we got 6 meters, right? And then this one is 1.5. It's 1.5 meters. So you clip that in. Now we have 3 and 3 is 6 plus 1.5. That's 7.5. That's pretty much exactly what we need for the start of this thing. So if I move this piece back here, right, and we move it and we line it up with the back end of the vehicle, like that, and then we move this, that's 7.5, we know we move on a 10 centimeter increment. Yeah, 10 centimeter increment. So 7.5, 7.4, 7.3. But it was 7.27, I think is what we've got on the calculator. So 7.27, that's exactly where the, basically the bottom of my tankage should more or less be, right there. Good. That should be the bottom fairing. And it's funny because it pretty much lines up. That's where the bottom of the fuel tank should be on the actual ship. But we have to, we have to make aft domes for this thing. Hey, Vidius, 74-month resub. All and Juan are identical twins. The mom only carries one baby picture in her wallet because if you've seen Juan, you've seen them all. Thinking about where these fairings need to be placed, because this is what I want to do. That one's going to pretty much have to be right. I'm going to say right there. I would like the distances between the back fairing. Because we need room for the thrust structure as well. Now it should be right there. Now I'm thinking. How do I translate that aft dome right there into a curved shape? Because what this rocket was using is actually the tankage doesn't match the outer tank wall. This was not using a common bulkhead. probably took principles from the Saturn V of not using a CBH here because RP wanted Carolocks. This is probably for structure. And not using the CBH up here because you have hydrolocks and you have hydrogen and oxygen up here. It's better to keep the tank walls separated, or else it becomes a tricky problem to solve. Three, 6, 9, 12, 15, 18, 21, 24, 24. Okay. Let's put that at the put this at the 12 mark. So 3, 6, 9, 12. I'm trying to make sure, I'm going to use these fairings to make the outer shell of the vehicle. There's no 10 meter, or there's no 20 meter tank in KSP without mods. Like, I'm sure there's a mod for it. I don't want to do that. What I do want to do is make sure that these fairing plates are basically going to be the internal structure of the rocket. All my fuel tanks are going to be attached to them, the fuel tank that we do put inside of our fairing shells, right? We do that to make it look like one big vehicle instead of a bunch of fuel tanks like all tapped together, right? But we need to take into account the dome piece. So it's got a dome up here, and then the straight section needs to be 12 meter. So let's move this back from 12 to 15 meters back. 1, 2, 3, 4, 5, 6, 8, 10. There we go. All right, cool. Yeah, we could just get rid of that aft piece for now. So let me get another one of the vertical. Line it up at the 12 meters back here, right there. It's perfect. All right, cool. So that's where we need to start the straight section. Oh, I screwed that up. Wrong button. The cylindric section of this needs to start right there. Now what I'm going to do is move those as far forward as possible. We know right here is where it needs to end. We know that from the interstage piece. So what I'm going to do is select fairing expansion on this. Right? And now what we do is build this fairing. Once again, you do not want to do straight like that. You need it to be tapered a bit because Kerbal understands the arrow better. But like I said, I offset the back of the fairing by 3 meters from where it needs to be so we can take into account this taper. What I'm trying to tell you is that Kerbal understands a more aerodynamic looking fairing. All right, now that needs to go right there. Nope, it didn't like that. Now this piece needs to go right. it's still giving me the option to close the fairing. So I will. Ooh, yeah, baby. Very nice. There's your outer tank wall. Now watch what we do here. We gotta still bridge the back section, right? And we know where it needs to start being straight. We know that it needs to do that right there. So take this piece, right? Take the mock-up piece, move it out of the way, hit save, and now we open up a file. I'm gonna open up the craft file that I'm working in. But here's what we're gonna do. We're gonna merge. Okay? We're gonna merge tanks together. Now watch. This is it. This is a really trick thing to do. I want to make sure that the second fairing that I make for the bottom part of the tank section is exactly the same. Now, once again, why did I decide on 2 fairings? It's just kind of easier if you use 2 for the structure of the vehicle. It will flop around a little bit, and we're going to need to strut it, but it gives you more things to attach to down the line of the vehicle. We could just use 1 fairing and then make it go all the way to the top, but I find that with a big enough fairing, Kerbal really likes to make them wobble. So we go to Prometheus R1, we merge, right? And now we have a copy of that thing over there, and then we shift left click. Oh, it didn't take it. Crap. Sometimes that works, sometimes it doesn't. Now, why did it do that? I think it did that because it's registering it as being closed on that fairing right there. So without that fairing, the game doesn't know where to close the logic. Okay, so let me go in here. I'm going to go here like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to move that back just a little bit. Okay. Now we're going to take my ruler control node here. Same exact thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let's go here. Let's edit the fairing. And instead of closing the fairing on our interstage, our conic interstage, I'm going to hit left alt left mouse button right here. Make the exact same thing. And now it's not closed on that fairing. So we should be able to do the craft file merge here. There we go. Put everything back into the right positions there. Have a nice smooth transition right there. Perfect. Now what you can do is like color the different bearings and stuff. I don't like doing that. Just keep it that way. All right, save. Now, actually, might be better if we made all these fairings two-sided fairings. Yeah, transition looks better. Cool. Save that. Now we go and merge the craft file with itself, and it should let me take that off. We'll see. Any idea if KSA has a robust VAB and rocket assembly controls plan? I don't know. I would hope so. Now we should just shift left click and we should be able to pull that thing exactly out. Perfect. Now we can attach it, make sure it's hollow. We can get rid of the original subassembly that we just merged. Now we just made the same piece. It's the same exact piece. We just copied it by merging it with our exact craft file. We line up the rim of that with that. Now it's one piece. There's your tank section. That's your first stage. There's your first stage tank wall. Done. Now, there are some tricks that you can do here. Because if we try to make these all work try to make this all jive together right now, the fairings will still move around. But remember what I said. This is why I made 3 fairings instead of making one big fairing, right? And then putting all my fuel tanks in. It gives you something to strut to. Now, what we're going to do is I'm probably going to wait until we... I'm probably going to wait until we put tanks and stuff in, but I can essentially strut the top of this fairing to the bottom, to the dome of that fairing, and then we can strut the top of this fairing, the rim of this one, to the dome there. You do that in 4x symmetry, this thing ain't going anywhere. We'll test it a little bit later once we have our tankage and everything figured out. Try out the metal texture. Whoa, why? We going Starship here? We can roll with that if you want. Hope you're doing well in the heat. It's 87 degrees in my office, Eric. It's we're not doing too well, but I'm fine, dude. I'm worried about my computers overheating. Like, don't worry, temperature's gonna go down tomorrow, but yeah. There, Hill. Sorry, I'm reading what you and Can't See Me are talking about. You became a weeb instead. Nice. Yeah, that's cool too. I think this looks good with the marked interstage. I think that looks pretty sick. 113 Fahrenheit in Spain. What's the humidity, Aitor? Your computer overheats when you try to merge too many ship parts. Okay, you're not wrong, but do I have a choice here, man? Alright, so now what we can do, we can delete that fairing, just leave that like that. 40 to 60? Okay, yeah, it's hotter there. It's hotter in Spain than in the northeast part of the US. That's good to know. Now, if we grandparent strut this, it's going to strut to the interstage. And if we grandparent strut the center fairing, right, the middle fairing, it's going to strut to the docking port right there, which is perfect. Now we're good. So, now let's work on the engine section. How are we going to do this? Save. Good call. Dude, this thing is going to be a chunky boy. This is going to be a chunky rocket. Wow. So we need a taper down, and the down taper should happen right here, just like it does there. Ours are actually, my bottom tank goes a little bit further. That's because we rounded some numbers. That's not a big deal, because that's the bottom of the rocket. So now that the tapered engine section, the low tapered engine section. Imagine if this rocket had a low taper engine section. This rocket's got to stand up, guys. I will engineer hold down points into this design because they're hold down points. Why would you not engineer that into the design? We're gonna have to, at the very least, we're gonna have to put this thing on launch clamps or something, right? It's got to go on a launch clamp, right? We got to put them on the launch clamps and hit go, and those launch clamps need to hold up the entire rocket. Let's be real, this is going to be like 3,000 tons of fuel when it goes. What's the name of this one? Prometheus is the running name for it right now. Like Prometheus and Bob. Yeah, we'll call, you know, we'll call the first stage Prometheus and we'll call the second stage Bob. Oh. No, we're calling it that because with a Prometheus rocket, a lot of fire. A gift of fire is going to come out the back of this. This is actually gonna be one of the bigger rockets that we've made. This is in line with Triton and Neptune, which is pretty cool because those are my big boys. Those are the big boy rockets that we used to make. But this thing is going to have a little bit more stomachy behind it. You understand? It's gonna have a little more stomachy. The gift of fire at 12 frames per second. Hey, you know what you need? You need the gift of shutting up. Why don't you exercise your right to shut the hell? You should sanction me with your arm. Oh, wait a minute. You don't have an army. Guess that means you need to shut the frick up. And that's what I'd do if I didn't have an army. I'd shut the frick up. You know, with each passing day, that Dave Chappelle sketch becomes more and more real. If you know, you know. It's something, Element. It's something, dude. It's a thing, bro. You know? Oil. Who said anything about oil, chat? You cooking? Oil? So let me get this straight. You're melting in your garage, and when you launch Prometheus Bob, you plan to cook your 3080 Ti and turn the garage into a sauna. Oh, I don't think we're going to launch the whole stack today, dude, but, well, I mean, maybe, I don't know. It depends on how much progress we make. It's kind of disturbing how well that bit still holds up in full. Dude, it's how is that possible? Does Dave Chappelle have a time machine, dude? Oh, wait a minute. Then you all need to shut the frick up. That's what I'd do if I didn't have it. I'd shut the frick up. It's pretty funny, dude. Anyway. Yeah, Adam, I don't know, man. Like, here's the thing. I'm looking at this thing right now. And you gotta understand that the majority of the components to this vehicle are already attached. Honestly, guys, Prometheus, I'm thinking it's going to be the entire rocket minus the payload, probably going to be less than 500 parts. This ain't no space shuttle, you know what I mean? It's not the shuttle where we built out every single individual tile out of freaking panels and made it work, right? I really don't think this is going to be that much, to be 100% honest with you. The engines and all the struts for the motors are what's going to take up the most amount of room. Have you ever Googled Cherenkov radiation? Might be a good idea to cool down your PC. I know what Cherenkov radiation is, and yes, you're absolutely right. But also, here, I got something for you. I found this on X the other day. Give me 1 second. So check this out. The Office of Nuclear Energy, who I should probably be following because that's pretty cool. I like nuclear. They posted, whoever's controlling this account posted this the other day. There it is. On the 17th. Watch this. This is cool. Bruh. That's sick. That's so cool. Oh, that's awesome. Quaid, start the reactor. Yeah, don't go swimming in that. Just a little tick. Oh, that's badass, man. That's some Star Wars stuff going on right there. I've seen that all systems, yeah. There's some great clips from the MIT test reactor just up the road from me. That's right. Yeah, that's Cherenkov glow right there. That's cool, man. What's going on in the pool? Toasty, so I'm not a nuclear physicist, first and foremost, but submerging, long story short, very long story short, submerging nuclear reactors in water is a really good idea. It's really safe. They work a lot better when they're submerged. That's the gist of it. The nerdy way of saying that is that water is a very good moderator of neutron flux in nuclear reactions. That's the right way to say it. Water, it's good to submerge it in water. It helps protect the radiation from going out. You can swim in that. I wouldn't swim down very far. Yeah, that's how, I mean, I just said don't swim in it, but you could swim on the surface of this. It'd be fine. I mean, I wouldn't. Why risk it? If you were down by where it's glowing, like you scuba dive down there, yeah, you'd probably be having a bad day. There was a what if by Randall Munroe that talked about this. You could swim in the top here, no problem. Yeah, you'd be fine. Water is that good of a nuclear moderator. You would not get it. You wouldn't get anything above like a normal radiation, like an X-ray swimming around in the top here. That's how good water is at moderating nuclear reactions. It's really good. It's like a freaking force field. That's why they submerge them. But I wouldn't do that. I'd be like, nah, I'm not doing that. What If is an amazing book. What If is a book by a NASA JPL engineer, a former NASA JPL engineer named Randall Munroe. It is intrusive thoughts answered by a scientist. Like, does flank steak make a good heat shield? Yes, it does. It ablates, though, just like anything else. Meat is actually an extremely good ablator for a heat shield. Yeah. It's actually really good at that. You want to know how? Here, I'll show you. Video 1. A Sainsbury 21-day matured beefsteak and Mach 5 winds recorded using Schlieren imagery to show the hypersonic shock wave. They figured it. It's a great heat shield, man. It's really good. It ablates really well. That's pretty damn good. That makes me laugh. That's so goddamn funny. Yeah, so one of the what if questions from Randall Munroe's book is what happened, if you drop the steak from orbit, would it cook? Would it cook perfectly? No. The answer is no, it wouldn't. And you know what they figured out from that? Randall Munroe's calculations were that you would basically pan-sear one side of the steak. Like anybody that knows anything about cooking, you'd sear one side of the steak. You wouldn't cook the whole thing through. Because with re-entry, you're getting all your heat from one side. It's not convecting the heat, which you need convection to cook the whole damn thing. It needs to have hot air all around it. Turns out if it's really hot on one side and really cold on one side is going to cook and the other side isn't, right? So they actually figured out some scientists in the UK put a piece of meat in a hypersonic wind tunnel to test this theory. Turns out that's exactly what happens. Meat is an extremely good heat shield. It's a really good ablative heat shield. It's carbon, right? It's carbon. I mean, a meat heat shield, a meat shield. Yeah. It works. That's a thing. That's absolutely a thing. I don't think that's very sustainable doing that, but it's a thing. Would it be cheaper to use meat? No. No, I don't think so, man. I don't think so, bro. Why does SpaceX care so much about good heat shields when they can just use the cows at McGregor? It's not reusable. It's not rapidly reusable. That's why. I don't think Meat Shield would pass a design review. Yeah, you're probably right. Okay, so we have our tank walls. Now we got to build our tanks. So what we're gonna do is, just so we don't get confused, I'm gonna rotate the fairing shell markers out of the way. I'm gonna rotate them out of the way. I'm gonna hit save. Right? Now we need to figure out our tank config. So, what would be a good way to do this? Let me think. We need rapidly reusable cows. Cows are already rapidly reusable. We've been milking cows for like 5 centuries or something. And I'm not I know science. I'm not a history guy. Like, I mean, I kind of am. You know, you find a historian. Or something. I don't know. Anyway, moving on. Yeah, the cows make the fuel. That's sustainable. Cows are more like the shuttle. It's reusable, but it takes a while. Okay. I think. I wish I was up. Oh my god! Can I do the tank design? Yeah, cool, good. Alright, what's the biggest fuel tank that we have? We obviously don't have a 20-meter fuel tank. Or, well, it's not 20 meters, it would be 10 meters. 10.6. We don't have a 10-meter fuel tank, but we have 5-meter fuel tanks. So let's go think about how we want to do this. Yeah, Aqualux has a long explanation of water being a good moderator in chat. Did the transfer tubes pass through the inside of the tanks like on the Saturn V? I don't think so. I think we have external downcomers. See the pipe right there? Subcooler? See how it goes down and it goes around, and see all these little nacelle things? I think it goes around the tankage. When you're getting into bigger scale like this, internal downcomers get really difficult to do. Our friends at SpaceX figured that out on Flight 7. They get more difficult, but it's doable. It's just more of an engineering challenge. So they use external downcomers. External downcomers simplifies the engineering, because you're not, a pipe going through a tank is just more points that the tank can fail. Supersonic retromupulsion. Cool. So these ones seem to have external downcomers. We don't have to worry about that in KXP. You don't need to worry about plumbing too hard in this. So we just place the tanks and just make sure that the tanks can have the right flow overlay and work correctly. Yeah, an external downcomer was a lot easier to engineer on the space shuttle, for instance, than an internal one. An internal one complicates the design, and with your external tank, which you were throwing away all the time, you don't want it to be any more complicated than it needs to. That's the reason why space shuttle engines ended up having autogenous pressurization, because you wouldn't want to fit out the shuttle's external tank with COPVs every single time and have tank ullage inside of the tank that you'd be wasting tons of COPVs every shuttle mission. So the engines repressurize. The engines have a pneumatic tap-off line on the space shuttle that repressurizes the external tank to take up the space of the fuel draining out. Most rockets do that, but the shuttle does it with its own engines. Starship also does it too. Starship does that for a slightly different reason. Starship does that for the reason why Starship does it is because Starship was designed to work out on other planets. It's as much a lander as it is a kind of space shuttle, so to speak, right? To simplify your ullage propellants, right? Because you're using gaseous methane and gaseous oxygen, it's a lot easier to operate something that's autogenously pressurized on another planet than it is like trying to find helium, for instance. Because tank ullage, if you're not using autogenous pressurization, is helium. It's usually helium. It'd be hard to find helium on Mars, at least initially. So they opted for autogenous pressurization like the shuttle. Same design criteria, but for slightly different stakeholder expectations and reasons. So here's a thought. How much harder would it have been to design Starship with external downcomers? On a booster, not too bad, Aqualux. Yeah, on the booster, it wouldn't have, I would at that point, I'd be worried about my propellants in the pipe heating up. Like when Super Heavy comes back in with no supersonic retro propulsion, I'd be worried about my external downcomers getting warm. And then cavitation at the turbo pump, which we know is a big no-no. That's a big no-no. Cavitation in the impeller, that's a big no-no. Right? So, I think internal downcomers are the right decision for the booster. Now, Starship, I don't know. How hard would it have been? I don't think it would have been much harder, but with Starship, now you'd have to tile over those, unless you put them on the top, right? Like, unless you put it on the leeward side. Like, yeah, I'm not sure. I've seen it, Baron. Is this KSB2? No. I don't play KSB2, Dennis. There's very few circumstances where I would ever play KSB2 ever again. Ever. I don't play that game. Aqualix, I frankly don't really get, like, I mean, I understand it, but I frankly don't understand how they got 33 engines to jive together fine and not 6. Dude, if that makes any sense. Like, what? How'd you do that? Would you trust anyone to make KSP3 at this point? I've said this once. Actually, in the past, guys, I've basically said I'd never play I'd never play any Kerbal sequels ever.
This is space.
The only way I would play any Kerbal franchise sequels, I thought about it, dude. I noodled on it for a little while. That's not exactly true. And don't get me wrong, I don't know any new information or anything. The only way I would ever play a Kerbal sequel is if Felipe had the intellectual property rights to the Kerbal name, the original guy that made KSP. That is the only way I would ever play it. I don't care who it is. I don't care who else it is. That's the only way I would play Kerbal 2 or Kerbal 3 or whatever, is if Harvester was making it. That's the only way. I don't trust anybody else. I don't trust anybody else to be able to carry out the vision that Kerbal deserves, other than the guy that made it, other than Felipe. He's the only one that understands how to do this, as evidenced from what happened. Imagine Dean gets to buy out the KSP brand. Maybe. Maybe. I mean, you never say never, right? But that's really the only way I would do it. So now we move these down into position. Was the Saturn tanks constructed in rings welded together or one big roll of steel? No, Saturn was not made out of steel at all. It was not made out of that. It's aluminum. There you go. I actually had the image very, very close. That's how they were made. So it's not that far off from how we make tanks nowadays. It's just the way to make those sheets of aluminum is a little bit different. We use stir welding instead of these things would have been TIG welded together by hand on a jig, which is, that's a vibe. But see that right there? And then they would have had internal stringers welded inside of them. Nowadays we use billet, they use billet aluminum. So they machine the structure into these plates and then put them through a gigantic metal brake to bend it. And then they put four of them together. I mean, let's just talk like Falcon 9, for instance. Falcon 9 would take 4 of these metal sheets, put 4 of them together to make a barrel segment, and then stir weld it together on a jig. And then the domes are made on a jig as well. Those would be stir welded together too, with a stir welder that basically goes, rotates 90 degrees. 90 degrees like that, right? And then they would use what's called a circumferential stir welder to put the domes on top of
space. I'm in space.
What's called a barrel. That's a barrel segment right there. This is how Falcon is made. What else is made? Vulcan is made that way. Atlas was made this way. Delta was made this way. The external tank on the space shuttle was made like this. Obviously, one of the domes is more pointy because it's the external tank. But yeah, and then the skirts are, the skirt assemblies right here are kind of made that way, but not exactly. These use what's called, these have stringers attached to them. So the stringers are the vertical things that provide structure.
Go at throttle up.
They used a corrugated design for this, like corrugated steel almost, but it's a special, it's its own thing because it's corrugated aluminum, right? And then they make the ring segments and then the ring bulkheads out of that. Nova gifted a sub to Baron. Montblanc, tier 3, 43-month resub. Merci beaucoup, monsieur. Thanks, man. Yeah, Starship is not made like this. Starship is made with rolls of steel, and those rolls of steel are rolled out into a ring, and then they weld the ring on one side. And then they take another ring and put it on top of it with its seam offset. So, like, one ring would be like this, the next one would be like this, the next one would be like this. They're rotated slightly to make sure that the seams you don't have two vertical seams meeting each other. Think like bricks. They're staggered. The seam between the rings are staggered. They're staggered for structural purposes. They figured that out in the Mark 1 days to not do that like that. Nah, Baron, that's the S1C, yeah. So with older tank designs, they didn't like billet. They didn't use billet. They welded internal stringers inside of them like that. That's the Saturn V first stage LOX tank, if I'm looking at that right. That's nowhere near completed. But yeah, see how they welded these kind of shelves in? Those are tank baffles. That's what they're called. The internal stringers are used for structure, but it's also used as a baffling mechanism. That's what this is as well. That's to prevent the propellants from sloshing around. Because, like, check it out. On a rocket, propellants can do this. They can do all kinds of things. They're actually very susceptible to toilet bowling, if you really want to know. Think like when you flush the toilet, it spins around. With a rocket fuel tank, you have the pickup at the bottom, and you can get the propellant swirling in there. That's why they put baffles down at the bottom. If the propellant swirls in there when your rocket is flying around, the water swirling is going to act like a gyroscope, and now you're going to be subject to intermediate axis theorem. Your stage will start doing this. Like if your stage is going this way, it'll start to kind of spin. It's the same thing like if you, in science class, they give you a bike tire. Like you had a bike tire with a stick through it, and you spun the bike tire and you tried to turn it. It basically wants to do that, and that's it. You can't like actually move it in different directions. Yeah, your propellants turn into a damn gyroscope, and it rotates your vehicle off course. That happened to SpaceX. It happened on a Falcon 1 mission. Their second stage just kept toilet bowling, and eventually the Kestrel engine's thrust vector control couldn't compensate for it, and it just spun out of control. It's free gyro destabilization for you. Yep. Yo, Patton, what's up? I think you need an AMSOIL hat. The P.O. box, dude. Just send it to the P.O. box. I'd wear that, sure. Now, we don't have to worry about anything. We don't have to worry about that in KSP. KSP doesn't have fluid dynamics. I just need to put some fuel tanks inside of this thing and call it a day. We don't have to worry about flow dynamics like that. Oh, the ladder. That's crazy. Good stuff. What is a Kestrel engine? The Kestrel engine was SpaceX's Falcon 1 upper stage motor. Yep. SpaceX abandoned the design when they switched to Falcon 9. Tom Mueller designed it. Tom Mueller's pretty cool. He has his own wiki page. Oh. Yo, Nader. Tom Mueller on X the other day, actually the other day, it was like 4 or 5 months ago, he posted pictures of what cars he has in his stable. Homeboy definitely owns a C7R. Not a C7, a C7R. The race car. That thing. Impeccable taste, I must say. Funny enough, the Raptor engine is made in a way that can cancel the gyroscopic precession caused by pre-burner turbo pump spinning. Yep. C5R is your favorite? Why? C7R will just lay a big chocolate fudge dragon on a C5R. 15 yellow Stingray. Nice. I like my Fords, but I can't hate Corvettes. Corvettes are just damn cool. You want to know? Here, I don't know what this says about me. Just on a quick side note. You want to know what kind of Corvette guy I am? That's what kind of Corvette guy I am. 94 Grand Sport. Now, I love that car. I'm never going to get one. I don't think I could ever afford one, but that is a sweet car. Quad cam, dudes. 4 cams in that thing. Quad cam. It's got dual overhead cam V8. It goes fast. It was an engine made by Mercury, not Ford. Mercury, a different company. Here's Tom's post. Now that's a Chevy I would. Didn't one of those go over like 230 in the 80s? Something like that, Dread. That's your car, Excalibur? You have a C7R, dude. Good for you, man. Not even jelly. That's just, I'm just happy some like people own these things because that's way out of my league, dude. Yours is stock though. I got you. So it's not a C7R. It's just a C7. What trim is it, dude? What is this? The 06? ZR1. Actually, I don't know if they made ZR1. Yeah, dude, he has a Porsche 99, what is it, a 991? GT3 RS with an Impulse Space logo on it. That's freaking badass, dude. Guy drives race cars and just has his Rocket Company's logo on the freaking side of his race car. It's basically every option minus the engine upgrades. It was a dealer car. Still cool. I mean, C7s are fast. Fast. We'll say fast. We'll call it a day. Okay, let's get back to the rocket. If you guys want to talk more cars on the other side of space news, this is going to be a long stream today, dudes. If you want to talk more cars on the other side of space news, I'm going to go work on my car in the garage. This is a live shot of the garage. I'm just waiting until the sun goes down. We'll keep working on the frame rails on this thing, fixing them because they were struggling. They were struggling. I'm almost to the point where I can hit this car with a hammer and no rust falls out of the bottom of the vehicle. We're almost to that. Close. How's the back been? I'm good, Big Zig. I'm fine. You have a car viewing tomorrow for a C180 AMG. Okay. Crew cab charger, man. Oh, nice, Tessa. There you go. Do I have AC in the garage? Oh, no. No. I barely have AC in this room, dude. Let me think here. I don't think that 4 tanks are going to be enough. And AX4. Well, AX4 is the reason why we're going long. Is this a Nova-inspired vehicle? No. It's not. Give me 1 second. This is a post-Nova inspired vehicle. We found a NASA technical report, dude, the other day about what vehicles would be needed after the Saturn series of rockets are no longer useful. So, no. This is what would have came after Nova, because for whatever reason, the Apollo engineers in the 60s had that figured out. I'm not sure. I mean, do with that information what you will. I got all my welding done, and I'm now working on paint. Nice, Chris. There you go. Yeah. This thing has 18 F1 engines in it. The Saturn V had 5. Nova would have had 8. This has 18 because... Alright. And it has 3 M1 engines in the second stage. The M1 engine is a vacuum-optimized Hydrolox version of an F1. 1.5 million pounds of thrust per. So that's about 7,000 kilonewtons per M1, and there's 3 of them in the upper stage. So we're talking 21 meganewtons from the second stage because bite me. Like, yeah. So I thought that this would be fun to make. A good little project for KSP. Kind of get back into it. You know what I mean? 18 F1s. Yeah, that's the engine configuration. I have it mocked up over here. Actually, that's 19 because I wanted a center engine because eventually I want to see if we can get this thing to boost back and land. So I added a center engine. I have 19 of them. Sorry. Forgive me. That might be enough, dudes. We're gonna have to test it. Now, I'm debating where we should attach these things to. You have to program a startup sequence with a cal controller. I mean, yes, Xerax, yeah, pretty much, dude. Why are the engines so far apart? To be condensed down later? Can't see me. I can only guess that that's the engine configuration because F1 engines really don't like being next to each other. They had this problem on the Saturn V. You got to keep these things far away from each other. It's part of the reason why, like on the Saturn V, you look at the bottom, the 4 outer engines are kind of far away. That was one of the reasons. The big reason is because the Saturn V was supposed to have 4 engines, and then they realized they needed more thrust, so they added a 5th in the center. Fun fact. And then because of heat, right, they couldn't cluster them. They couldn't cluster them like that because so they moved them away. If you look at some Apollo launches, dude, it's hard to see it. But the F1 engines, even being that close to each other, were wrapped in asbestos. They just took asbestos blankets and like taped them onto the rocket motor because that was the only way to keep the F1s from melting each other. Yeah. Yeah, every Saturn V launch had just look at them. See, you could see the asbestos blankets. They're just wrapped around them. That's how they did things. That was their way of solving that, because clustering these engines together, the heat, the convecting heat from one would melt the outside of another. That's still a problem with rocket engines. But I mean, that's another reason to make smaller rocket engines. You make smaller rocket engines that don't give off as much heat, which is why stuff like Starship, you know, and Falcon have a lot of engines that are seemingly really close together. But the crazy thing about that is that if we look at some Falcon pictures and you see the engine sections, the engines are actually a pretty good distance apart from each other. There's a very good reason for that. So the nozzle doesn't, one heat from one rocket engine doesn't melt another. They're actually spaced apart pretty far. It's a lot further than you might think. Now Raptor, that's another story. They got those things. Part of the stakeholder expectations and design for Raptor was to make sure that they can operate close to each other. Show the injector, you coward. No, I don't think I will. Freaking Air Force posted that. Just... How much gimbal did the F1s have? In Kerbal or in real life? I think it's 5, Dragon. I think it's 5 actually in real life and in KSP. Fun fact, because they added that 5th engine in the center late in the design, a Falcon or Saturn V center engine has no thrust vector control. It's the outside engines. The 4 outer engines are the ones that can move. Yeah, the center engine on a Saturn V has no thrust vector control. Yep, the outer engines on a Saturn V are what steer it. Why is the exhaust black and then becomes normal on the F1? Oh, good question. It's because it's a closed cycle gas generator. Hang on. Trying to find the right pictures. It's a closed cycle gas generator. So, Wartos, do you see these things right here? That is a gas generator recirculation manifold. So, rocket engines, most rocket engines nowadays, I mean, there are exceptions, right, have basically a jet engine attached to the side. It's a jet engine, but it doesn't have an intake. The reason why it doesn't have an intake is because where the rocket goes, you don't have air. So a jet engine on the side with an intake wouldn't be good. Now, what are they using that jet engine for? This jet engine, which in very literal sense is a jet engine, this engine is actually not used to drive a compressor. It's used to drive a fluid impeller, a pump. So you have a turbine attached to a pump. They're called turbo pumps, right? Now on the Saturn V, on the F1 motor, you have a jet engine which is in the form of a gas generator. It's like if you took a turbojet and you cut the compressor off. So you have a combustor, and then you have a turbine. How do they, okay, so how does it work if it doesn't have the compressor? Well, they spray liquid oxygen into it, and RP1. They spray rocket fuel into this jet engine, into a combustion chamber, and it shoots out over the turbine. That's called just a gas generator. That's why? Because it generates a lot of gas, but it also generates horsepower in the form of shaft horsepower. So this is like basically not really a jet engine, but more like a helicopter engine on steroids, right? And what those do is they turn your fuel pumps for the engine. They turn your liquid fuel and oxidizer pumps for the motor. The pumps spray into there. Some of that gets tapped off to use the generator for the gas generator. And most of it, like 98% of it, goes in here. The other 2% goes in here. Now, important thing, jet engines can overheat. They overheat. How do they overheat? They overheat with mixture. If you over-oxidize it, or a jet engine ends up running lean, it'll melt. Just like any other combustion engine, it'll melt. That's what that is. The gas generator is a combustion engine. It's just not an internal combustion engine, right? So, what's going on here is with your gas generator or your crazy jet engine here, they run extremely fuel rich. That is a very easy way to keep the engine cool so it doesn't overheat. If you ran these gas generators at stoichiometric, so like the ideal amount of fuel and oxidizer, they would melt. Where it is, it's very hot. I don't know if you could discern that from this picture. It's pretty warm, like all up in here. It got so warm up in here that they like I said, they needed to coat the engines with asbestos blankets to keep them from overheating. Got really warm. So the gas generator gets really freaking hot. But to overcome that, they run fuel rich. So they run a lot more fuel in the gas generator and basically flood it as best as you can so it doesn't overheat. But it's the happy balance between flooding it and getting it to not work at all, but also putting enough fuel in there, your oxidizer to fuel ratio in there to keep the thing cool. Now why introduce more heat into a gas generator? Why would you do that? Despite what you guys may think, we have perceptions about gasoline, for instance. Gasoline is very explosive, so you'd think heating it up, right? Heating up is bad. Well, no. Gasoline is not explosive. Not by itself, right? You have to combine it with an oxidizer. It's not the gasoline that's flammable. It's the vapors that it makes after the gasoline is combined with atmosphere. That's what's explosive. That's the part that blows up. Right? The funny thing is that essentially that's what that's doing at the injector plate. It's making vapor. It's making fuel and oxidizer vapor, and then it blows it up and shoots it out the bottom. That's a rocket engine in a nutshell. It just accelerates gas outwards very quickly, right? But the thing about fuel, like RP1 for instance, rocket propellant 1, or just kerosene. Kerosene is made up of hydrocarbons, so hydrogen and carbon in chains, right? Hydrogen and carbon are both very conductive of heat energy. Gasoline is really good at tanking heat. It's really good at that. You can introduce a lot of heat into gasoline before it'll pop, right? So it's very conductive of heat, like copper is very conductive of electricity, or metal is very conductive of heat, right? Fuel is extremely conductive of heat. It's very, very good at it. It's very good at tanking it. You can introduce a lot of heat into it before it blows up. So in the gas generator, they run fuel rich. So if you're running fuel rich, you're going to get a lot of unburnt hydrocarbons coming out of the gas generator exhaust. What they did here was they introduced the gas generator into a recirculation manifold and used that unburnt hydrocarbon coming out of the gas generator, because they figured out that you could absorb way more heat, but it was enough to keep the gas generator running really good, right? But the fuel that was introduced in here, right? It had more room to tank more heat. So they put it into the recirculator, and the recirculator evenly distributes it in the nozzle. And what that did was keep the F1's nozzle extension nice and cool. They did it by basically film cooling it. They film cooled the thing. They used the unburnt hydrocarbons coming out of the gas generator, they figured out that they could take more heat, and they introduced more. They introduced it into the nozzle extension, right? And those hydrocarbons got introduced to even more heat. But that cooler column of gas between the inside wall of the nozzle and this stuff right here, the explodey bit coming out the bottom, right? In that little kind of area, that little small area, they dump the hydrocarbons in. And what that does is the hydrocarbon tanks the heat. The fuel, your unburnt fuel, tanks the heat. And it keeps the nozzle from melting. Now, from the recirculator manifold forward, the F1 engine used regenerative cooling channels. It used liquid oxygen being pumped through to keep it cool, right? But the nozzle extension, nope. They were worried about it melting because it still gets really, really hot without the liquid oxygen flowing through it. It ain't gonna work. So what they did was they dumped the gas generator. They dumped the gas generator exhaust in. It provides a cool column of gas between the inner wall of the nozzle and your exploding gas, the very hot gas that comes out, and it keeps the nozzles from melting on the inside, not the outside. That's called a closed cycle. Yep. And even then, they were still worried about these things melting. That's how much kick those things had. Everybody got that? Good! Now, here. Let's see how well you retain that information. This is going to be on the test. Now, here, check this out. Cool thing. You guys know Falcon 9? We watched the transporter mission yesterday, right? You know the first stages come down and land, right? When they launch, they're ideally clean, right? When they launch for the first time. When they come back, they aren't so clean. You tell me, given the information that I just presented, Falcon 9's first stage engine, the Merlin 1D, do you think that is an open cycle or a closed cycle gas generator? Hint. Look at the booster. If you said closed, you're wrong. It's an open cycle engine. The reason, the way that you can tell, right, is with the Saturn V, you saw a small area of black soot, and then there was nothing below that, because the rocket exhaust was burning off the rest of that unburnt fuel, but it was just doing it down below. With Falcon, you don't see that. What you do see with Falcon is that when it comes back down and lands, it does that supersonic retropropulsion thing that I'm a big fan of. The engines are open cycle, meaning their gas generator exhaust, very fuel rich still, because old tricks is the best tricks. The gas generator exhausts, you can see them right there, they're shooting out incredible amounts of soot. And when Falcon 9 flies backwards, doing the supersonic retropropulsion and flies business end first, the rocket gets coated in that soot. It's open cycle, baby. You can see the gas generator turbine exhaust right there. That's it. Every single one of them has it. If it was closed cycle, you wouldn't see that happening. The boosters would come back more or less clean, because most of it would get burnt off in the nozzle, like it did with the Saturn V. Pretty cool, huh? Now, the Merlin vacuum, which is not a Merlin 1D engine, uses a closed cycle. They use a closed cycle to keep the nozzle cool for the same exact reasons, dude. Yep, same exact thing, dude. Merlin vacuum, if you look right there, has a recirculation manifold. You often see solid oxygen and ice getting caught on it during a mission. Yep, closed cycle on the second stage engine, because that nozzle is gigantic. You have to keep it cool. Now, the hottest parts of the rocket engine are in the combustion chamber, and then right after the throat. Now, SpaceX uses niobium, a niobium alloy, to get the metal to glow but not melt. And the metal glowing is actually what keeps the nozzle, the extended part of the nozzle, nice and cool. But they have a recirculation manifold in there to keep this forward part of the nozzle nice and cool. If you notice during Falcon 9 missions, when the second stage ignites, the back of the nozzle glows, the front of it not so much. It's doing the exact same thing. The fuel keeps the smaller part of the expansion of the nozzle here nice and cold. The F-1B was open cycled, Max, yes. See last, please. Use this when students and their parents are on a tour. It could help. Oh yeah, that's nice. Does this count as a closed cycle? Closed cycle is when the exhaust goes somewhere else other than being dumped overboard. Now, don't get open cycle and closed cycle confused with stage combustion cycles. Combustion staging is different than open and closed cycling. Those are two different things. They sound very similar though. What do the RD-107 and RD-108 use? I know they have a single shaft turbopump for everything, but do they use RP1? Modern versions of Soyuz actually run off naphtha. Yeah. They run off naphtha. Cheaper. All right. Okay, so let's get back to our fuel tanks. I'm not sure if that's going to be enough fuel for our first stage, so... Now, if I attach this fuel tank to that fairing plate, right? If we do that, that would be the strongest way to make this. So strut that fuel tank there, attach the big fuel tank to the small fuel tank, and then strut the two tanks to these fairing plate segments on the way down. That would be the best way to do this. The strongest way to do this. But there's a catch here. I don't want to go through a stage separation here, like when we stage the vehicle. Go to fire this and have my rocket engines fire into this thing and have that fairing explode. Because if we, during staging, we fire into it and it blows up the fairing, the entire first stage will come apart. If all of my stuff is attached to our tapered interstage right here, the conic interstage, and the conic interstage blows up, the entire rocket will just free float. Now, that isn't to say that even if I didn't attach the fuel tanks there, that this blowing up would be good or bad for the rocket. It would be bad anyway, so we should probably make sure we adjust our staging. Even if that doesn't work. I talked myself out of that by explaining it to you guys, sorry. I was thinking attach fuel tanks here instead, but you got to think about it like this. If we blow off the top of our first stage, you know, I was thinking attach the fuel tanks back here because, you know, if we stage and it doesn't work, it just blows up the fairing and it doesn't blow up the rest of the vehicle. Now, one, a fairing rud right there means a fairing blowing up technically inside of this fairing because that fairing is cupped over that fairing. It's kind of encompassing it, right? If that thing pops, the whole thing's going to go kablooey anyway. So I was thinking attach this here in the event of staging not causing a gigantic explosion. But the reality of the situation is, even if the fuel tank is attached here or attached here, and it blows up, it's probably going to blow up the entire stage. I mean, so in that regard, we should probably make sure that when we stage and fire these engines, that they're a good way away from this, not enough for the rocket exhaust to actually pop it. We're not hot staging here. Could, but if we're going to hot stage, I wouldn't use that. I wouldn't have the conic stage in there. So the more I think about this, the more I'm thinking attach these tanks in 4 times symmetry to here like this. Oh, dude, I thought of something cool. Attach the big tank first. So now, big tank's back. And what we can do is, I noticed that this thing has a bunch, this vehicle has a bunch of external downcomers around the tank. The pipes from the LOX tank go around the RP1 tank. They go around them. We can do something like that to make this look cool by taking these fuel tanks, right? Rotating them like that, and we could have the downcomer sticking out. By doing that. And we get the exact same effect. There's our external downcomers. We're not hosting an intergalactic kegger here. No, we are not. Do hypergolic engines burn stoichiometric, or is that completely different? That's a good question, Tanner. You know what? I'm not sure. I actually don't know. I would assume yes, but now that I'm really thinking about it, I'm a lot more familiar with RP1 and LOX, because that's more like diesel fuel and gasoline and diesel fuel I have a lot more experience with, like messing with cars, right? I do not have a lot of experience messing with hypergolic propellants. Not that you should, but I actually don't know. That's a good question, man. I'm not sure. I would assume, well, let's think about this. You have monomethyl hydrazine as your liquid fuel and nitrogen tetroxide as your oxidizer. Now, what's monomethyl hydrazine? What's its chemical makeup? Let me take a look. H2N and HNCH3. Let me put it to you like this. If I was using hypergols based off of the information given here, you could use monomethyl hydrazine. You could use hydrazine to do the same thing. These aren't hydrocarbons. Chemists will kill me if I say that. But you do have a lot of the same stuff. You have a lot of hydrogen, you have H2 there, you have H there, you have H3 there with a carbon, right? These are all good heat conductors. Nitrogen is okay at conducting heat. So you could probably, I wouldn't run these stoichiometric. I mean, you'd have to, from here, what you'd have to do is have to figure out, like, one MMH and one NTO, when they combust, right? How many joules of energy does that give off combusting one of these things? From that, you could probably discern your total, what would it be? Specific heat from there. I'll be honest with you, just what I see here in my completely armchair rocket scientist uneducated opinion, it'd be better to run a fuel-rich stage combustion with hypergols. Just based off of what I see here, you could use monomethyl hydrazine to tank heat in the same way that kerosene. You could do it with kerosene. You could do that. That's just with my honest, like, 5-minute assessment of the situation. I see hydrogen and I see carbons and hydrogens here. You could probably get away with it. Yeah. I would run, even if you weren't running like a stage combustion, I would run fuel rich. because that is a very quick and easy way to make sure your rocket engine doesn't melt. MMH UDMH is used over straight hydrazine due to the increased thermal stability that helps with regenerative cooling. So unsymmetrical dimethylhydrazine. Yeah, a monomethylhydrazine or unsymmetrical dimethylhydrazine. Yeah, exactly, Jack. You would know this stuff, dude. That's why I was like, I didn't call this a hydrocarbon, because it's absolutely not. Hydrocarbons don't have nitrogen in them. I'm not trying to piss anybody off here. You know? I'm just trying to figure out the right placement for these tanks. Does that stick out the bottom at all? No, it does not. Okay, cool. So now we're going to run some struts. So with this one, we have grandparent strut, and because the grandparent strut is picking up the 4x symmetry right here, it's running a grandparent strut to that tank, and then it's also running 3 grandparent strut to these other tanks, because grandparent strutting works over symmetry. This one, with its grandparent strutting, is strutting from this tank to the front fairing right there. Okay. Now these ones, grandparent strutted, the big tank, are strutted to the docking port through a grandparent strut. Cool. That should be pretty dang strong. Now what we have to do here is secure these tanks in place. Now, I'm not too worried about all the tanks strutting to each other. Once again, with auto strut, they're all connected. Not too worried about that. But we also have to make sure that my tanks are connected to the fairings, which are technically the outer skin of the rocket. Now, for a primary load pathway here, what I'll do now is we will run a set of 4x symmetry struts. I'll run them from, actually, it'd be better to run them from the fairing back to the, no, run them from tank to fairing like that, because it's the end of the hierarchy, like this. How you attach struts actually makes a difference, guys. To speak how this works grammatically in English, the strut is attached to the tank, which is then attached to the fairing. We could do this in reverse. We could have the strut attached to the fairing, then attached to the tank. But the struts are at the end of, they're on the outside of the hierarchy, and they're not in the primary load path. Because remember, the fairing is what's going to be pushed up on. Because all my engines are going to be attached to this. That fairing is connected to that fairing that's in there, which is connected to the front fairing, which is technically pulling the tanks up in this design. But we want to help offset that load. Hey, MacB. It's been this long. It's been 84 years. Now, what we could do here is do the same thing on the second set of fairings, or second set of tanks, right? And strut them to said fairing. Strut them to the fairing plate like that. That goes from those tanks to fairing plate. So now these tanks are picking up on the fairing plate, and that one is picking up on, and the mid tank is picking up on the fairing plate. That's good. That's what we want. Now with the back tanks, can do is we can run a set of struts from the back tank to the aft dome on my fuel tanks here, like that. We have not designed our thrust structure for this, so I'm just going to kind of leave them at that. Now, cool thing about this is that if you go to a fairing and you unclick the mouse over option, the fairing becomes nice and solid. Strutting to the fairing plates is one thing, but if your fairings are solid and you don't plan on staging them at all, these aren't fairings to deploy a payload, they're fairings that are being used for the aerodynamic shell for my tanks. They're not, if these fairings are deployed, we did something wrong. So now what you can do, and how I'm going to do this is a good trick here. It's spinning. It's a good trick. I'm going to rotate the entire assembly 45 degrees. And now I see these gaps right here. Now what we can do is we can strut the tanks to the fairings. Now here, I will show you how to do that. You can see right here is the bottom of our conic interstage. That's the bottom of the fairing. If we take struts and we put them in 4 times symmetry, right? And we run a set from there to there. We run another set from there to there, right? Actually, you know what? We don't need to rotate this 45 degrees for this type. I screwed up. I rerouted by accident. I fat fingered the keyboard. Reload. It's no good. I don't trust part rerouting. Part rerouting breaks things. We only lost a little bit of strut work there. I'm not too worried about it. And hitting the undo button in Kerbal causes a memory leak, which causes your computer to get warm. I'm trying to avoid that today. Yeah, I'm trying to avoid excess heat in this room that I don't need. Yeah, we don't. Yeah, we don't. That's bad. Yes, I have the air conditioner on and all the fans are on too. It's just too much heat for the air conditioner. Yeah, it's not good. I should do something about it. Now the back struts, I haven't completed the engine section, so I just won't do those. But now, what we got to do is go back here, set our fairing to mouse over, or get rid of the mouse over option, shut it off on all 3 sets of fairings that are making the primary structure of this fuel tank. That's our first stage, by the way. Yeah, that's the size of it. It doesn't have, I don't have the back tapered section, but that's the size. Look at the Kerbals down at the, walking around on the floor to give you some sense of scale here. It's pretty big. This is a pretty big piece of equipment. There is an undo button. Forget that the undo button exists, dude. I'm telling you right now. Forget that it exists. The undo button in this game does work, but it's not great. That's bad. Total protonic reversal. Okay, yeah, thanks. Good safety tip, Econ. Wait, I need to know. Where is it? No, you don't. I'm not telling you what it is. It will break your game, Cake. You're not listening to it. Trust me, dude. You do not want to hit the undo button if you're working on any semblance of a complex build in KSP. It will break stuff. It'll break your game. It'll break your craft file. Trust me, don't mess with it. Should we not start with building the launch pad first, my old friend? Warhammer, no. I would not start. When I'm working on a vehicle, if we're working on mission mode rule style vehicle, launchpad would not be the first thing that I make. You need to have a critical design review on your flight vehicle. You can't build a launchpad for a vehicle that doesn't exist. Believe me, they're trying right now with SLS Mobile Launcher 2. Because that's the hallmark of fiscal responsibility, designing a launch tower and a mobile launcher for a vehicle that doesn't exist. Not smart. No, I will put the provisions in for a pad for this dude, but I'll be 100% honest with you. This thing is probably not going to get one. I'm not sure if KSP can handle any part in KSP can handle holding up this type of vehicle. Please make it so it can launch from the stock pad. With that being said, we still need to hold it up with launch clamps, dudes. It still needs to be held up somehow, so we're going to need attachment points, or at least something to attach to that can hold up this vehicle. Guys, we haven't even completed the first stage. It's already fully fueled, already over 2,000 tons. This vehicle's going to be I'd say, if I had to guess, probably like 3,500 tons, probably. That's heavy. I'm not sure any part in KSP, I'm not sure there's anything we can do to hold this thing up with a reusable launch pad. But maybe that's a challenge for down the road. Alright, so now we need to strut to the fairing shell. That's what we were working. That strut is in 4x symmetry. Now we need another one up here, catching up off the same load area. There we go. Okay. Now the other thing that those are fine. Those struts will work. The other thing that we should do is take these struts and move them forward one tick with absolute. We should put a strut directly behind them. And that strut should go to the fairing shell. Then we should have another one, or XSim, that does the exact same thing, like that. Crisscrossing struts like this usually helps. But I'm trying to hold these tanks, which are like 300 tons or something by themselves. I think they're like 280 tons or whatever. I'm trying to hold them in position. They need to stay centered inside of the fairing. If they're moving around inside of the fairing on the way up, gonna have a bad time. Now, on the back end of the tank right here, we can do another set of struts that basically do the same thing. That. Then we take this, move it a couple of ticks forward. And we do the exact same thing. I always take the time to place the struts correctly. Make them look nice. always take the time to do that, because that means sometimes Kerbal just likes to run random struts. It just will run a strut off in a random direction, and it's very annoying. So what we should do, each other rotated correctly, and then absolute. Absolute snap, so they are intersecting with each other. Now these struts I don't worry about as much, but we could do that too to make sure they're nice and aligned. Like that. We should probably do that up here as well. This is a good indicator for me if they're, like, I know that if the struts are aligned and pointed at each other like this, it's a good indicator for me that I place those, because Kerbal does like moving struts around on you sometimes, especially if you hit undo. It'll screw you up. You don't want that. That and angles of struts absolutely matters in terms of structure. The angle of the dangle makes a very big difference. That's what I'm trying to tell you. Now I want these struts on the second tank in line here. No. Nope. That's not what I want. Why did that one go and the other one didn't? Alright. Alright, we'll rethink this. Give me 1 second. Is this Nova? No. Pop, we found a PDF on NASA Technical Reports about this is what comes after Nova. Yeah, this is what comes after Nova. This is post Apollo-Saturn architecture. Say it. Okay. Have you heard about the crane that fell at Massey's? Yes. That's not good. Now these are strutting to the first fairing shell, second tank to first fairing shell, and now what we need to do, and the reason why I moved these struts outboard is because I want a strut attached here from the top of that fuel tank, right? From the top of the second fuel tank in line here, this fuel tank, the S4256, I want a set of struts run in the exact same configuration that they are run from the first tank, from the back of the first tank. And I know what people are going to say. You got enough struts here, pal? And the answer is, oh yeah. Yeah, you're damn right I do. Look, this vehicle's going to weigh like 3,500 tons. And it's going to have... it's going to have like 50 meganewtons of thrust, which is insane for a Kerbal rocket. That is an insane amount of thrust for a rocket in KSP. Like, let me put it to you this way. This Prometheus rocket was designed, it's designed for Kerbal's solar system. This could probably get payload to orbit in real solar system. In RSSRO, it could probably do it. That's the type of forces that we are dealing with here. Crane fell at Massey's. No, we're just saying that to make you feel bad. Yeah, a telescoping crane from the looks of it. It looks like yeah, was having trouble lifting the payload. Yeah, so long story short, dude, I don't think this is gonna be enough struts. We might need more. I don't like keeping the struts actually buried in the fairing like that. I like having the struts where I can click on it. So I'm actually gonna revise that decision. Go. Could this launch a full MLV into orbit? I don't know, Pigzig. It's whatever it's going to do. It's going to do something. Yeah. What that is, I don't know. Now for the back part here, just need another set of struts here. For what it's worth, I haven't done any load analysis on like when struts break or when they fail, or like deflection or anything. These struts are pretty dang strong, and we'll leave it at that. It would be good to do some calculations here and analysis on struts, and then you can figure out exactly where you'd want them. But that should be good enough. Now with the back tanks, because there's no like dome piece or anything to attach to, we can just, for the back tanks, we only need one set. One set of these are fine. For the other two tanks, I opted for two sets of struts because they're big. No, auto strut doesn't risk messing anything up. Unless you reroute. If you reroute a part, it can mess up auto struts. If you reverse the polarity of the struts by rerouting from the back of the vehicle to the front of the vehicle, your vehicle will not work as intended. No, that's not me making up big words, I swear. It won't work. Just gonna move the stage forward a little bit so I can work on it. Now the tank-to-tank strut. So yeah, I don't think we need to do those. Let me check the grandparent strut. Yeah, okay. These ones are going to need to be strutted tank-to-tank because the grandparent strut isn't connecting. And I'm willing to bet that this one probably is not doing that either. downcomers in the way. How are you going to design the thrust puck engine mounting? Jazz, tree. Think a tree turned upside down. As we get further and further away from the center, the proverbial center of load, so your primary load carrier right there, primary load carrying Kerbal, like that's where we got to push up on that. We might be able to get away with just attaching 18 engines to it and then gizmoing them out into various positions, hitting grandparent strut, calling it a day. That might work. Might. But if we attach, we have like a center thrust puck and then an outer thrust puck, like Super Heavy. Super Heavy does that. It has two different thrust pucks at the bottom. Actually, three, if you really want to be technical. There's the outer ring of 20, there's the inner ring of 10, and then there's the three in the center. Super Heavy, how it's made, it has three thrust pucks kind of rolled into one. There's three thrust structures in there. They're all tied in together. I know this because, which one was it? Flight 4, I think, where the Super Heavy did the soft landing before. It was Flight 4, before they caught it. And they went and fished it out. Do you remember that shot Elon posted of them pulling the ring of 20 from Super Heavy out of the water in one piece? Different thrust structure. There's three thrust structures built into each other there. I'm going to do the same thing. We're going to build three thrust structures into each other. There's a really cool way to do that, dude, and I'll show you how. I'm really good at getting things in Kerbal to beat the Kraken. That's really what my specialty is for the people that don't know me. You've never seen me play Kerbal. You discovered me through NSF. I'm very good at doing this. That stage right now is extremely strong. It should be, with all these struts and all these placements the way they are, it should be able to withstand any force like we should be able to push up on it, and the fuel, we don't have to worry about the fuel tanks breaking apart. It's not going to happen. Now, unless I missed something in particular here, but I don't think that I did. Gotta make sure that these tanks are all strutted to each other, though, so they don't move relative either. Like that. So that's at the top. Now we got to do another one down here at the bottom. I'm basically picking out all the places where the tanks can move around. Right? And isolating them. I'm trying to make sure that these tanks do not move on any axis relative to like where they're placed. I don't want the tanks doing this, right? I don't need them doing that, and I don't want them doing this. So I'm isolating all axes of the tank. You would do that in real life by using stringers. That's what a stringer does. So you guys know Starship has all those like stripes on the outside, like up the texture right there. It has all those like C-channeled stainless steel attached to it in certain spots, like at the Common Dome. That's because they don't want the Common Dome deforming during flight. That would be very bad. It would explode. Did you mishandle a COPV? I haven't. No, not me. I might mishandle the entire rocket because it's Kerbal, but you know, Sean, it's fine. It's fine. It's okay. Oh, switching to the other music was a smidge louder than what I had before. I apologize about that. Now down here, we're going to need to do the same thing. Take over. And the last bit here. I prefer the internal strutting over the external stuff. Like putting the struts out here. Because I added those struts, we probably don't need, and by probably, pretty sure we don't need those ones, but you know what? Send it. 4 extra struts isn't going to screw us completely on the part count, guys, believe me. Your call is important to us. Please stay on the line. Our next available operator will be with you shortly. What's the part? Second row, first slot. That's a custom part that I made, Adam. Look, I'll show you what it does. It's a clevis. Watch. See that? It sandwiches, that clevis sandwiches the hinge, right? And if you take this part and hit same vessel interaction and take that part, the top and the bottom hit same vessel interaction, struts don't drift. Or not struts, hinges don't drift. Yep. It's a robotic joint reinforcement piece. 2 parts here, 2 parts there, we're at 800. Only at 234 right now, Kem. Just saying. Like I said, I think 500 for the whole stack. That's what I'm thinking. It's not going to be as much as you might think, dudes. Just because it's big doesn't mean it's a lot of parts. I've been thinking about this over the weekend, but couldn't figure it out. Why is it that you can use atmosphere engines in both atmosphere and vacuum, but only vacuum in a vacuum? The nozzle flykin. You need a bigger nozzle up there. And a rocket engine with a bigger nozzle that's designed for up there working down here, it gives you uneven heating in the nozzle. The reason why is because you get flow separation inside of the nozzle. Where can we find your custom parts? I have not released those. The hybrid tech hinge piece, I haven't released it. Maybe I should. I was saying, and people have actually sent me a message. I was saying earlier in the stream, I need to finish texturing these. I want them to look like the stock hinges. I want them to look like they belong. Now, I did do the top piece, basically lifting Rover Dude's textures, right, to make it look like the piece. Now I got to do that for the bottom. It was untextured. I never finished it because I got upset at using GIMP because I hate that program. So, yeah, if somebody, I said, you know, shoot me a message if you want to work on this. Make a stock-alike texture for it. Then maybe I'll release it. Or maybe I'll just finish texturing them. I don't know. Okay. We should probably go putzing around with the first stage here. Did you use Blender? I used Maya. I have a legit version of Maya, Max. Yeah. It's Maya LT 2018. So the root for each stage is the small girder segment. Well, that's just a control node, Nova. The docking port. The docking port is the root. That's going to be the root part of the first stage. There are other reasons that I forgot to tell you a little bit earlier why the docking port is the root and why I don't want a lot of connections between the top of the top root part and our proverbial bottom root part. So basically where our launch clamps would be attaching. You don't want a lot of connections in between. That has to do with pad integration logic, but you get the idea. All right, I'm sick of that song. Bring back the Suno music. When it comes to designing the staging system, you should add hydraulic pushers or ullage motors to push. I'm probably going to use ullage motors with this design. Hydraulic pushers, dude, that second stage is going to be freaking massive. Dude, the first stage is 2,000 tons right now. I mean, keep in mind, it is full of fuel, so let's take the fuel out. The first stage right now is 400 tons and change. Dry. That's more than super heavy, guys, in real life. Like, that's because every freaking part in KSP is made out of lead. But that's another story. Help. 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 I'm gonna fry something, man. Help. Brother, order a new air conditioner? Dude, it's blowing cold air. It just can't keep up. It's just too much heat. This thing's blowing a lot of cold air. It's just not getting to the computers, man. Everything is insulated in the office, dude, and the shop for what it's worth. That's a 10,000 BTU air conditioner, man. It's not enough because we're pulling heat basically from the garage, dude. Yeah. I don't want to talk about it, guys. Everybody turns into an HVAC expert when I talk about this. So, yeah, it's just hot, dude. I shouldn't have even brought it up, but I looked at it and was like, yeah. Would the first just wait to separate from second stage in real life? Ask that question again, John. I don't understand what you're saying. The humidity is a killer. It is, man. Hydrate time? That's probably a good idea. I've seen you've seen Technology Connections various HVAC vids. Yeah. Creeper, why are you sending me the space? Oh, it's freaking 5 o'clock. Wow. Kerbal still makes time fly. After all these years, man, that makes me happy. That makes me really happy, dude. Too many off tangents make it fly. Hey, most of my tangents were pertinent to subject matter. Give me a break. I don't want to take a break. We're cooking, man. We're cooking. Look at this first stage, dude. She's a beast. I don't like those things sticking through like that. Safe to say you still got it? Actually, Nova, you know what's kind of crazy? It's very clear in my head nowadays. Like, you know, like when you don't do a thing for a long time and then you go back and do it and you're like, wow, oh, this is easy. You're right, you are cooking. Yes, I think I might be cooked, actually. Like actually, I think I might be cooked.
Go and throttle up.
Dude, you know what's nuts? That's inside. It's even hotter outside right now. Hey, Pleck, 57-month resub. Thanks, dude. Think I might be cooked, man. Freaking roasted, dude. Keep hydrated. Thank you, Space Pope. Oh, actually, you know what? That's the control node for my rulers. All right, let's finish this. Let's finish the tapered section of the stage, and go from there. So, give me another 5-meter fairing. This one's gonna have to be facing down. No fairing staging. Gotta go in here and find my ruler control node. There it is. Move the ruler control node backwards. Ah, dang, I almost got it right. Poop. I almost had that. Where did we screw up? Try that. Okay, so that's the aft skirt for the whole thing. Actually, you know, I could probably move. We don't need to make that nearly as big. The skirt doesn't go all the way down to the bottom of the vehicle. It exposes the nozzles down at the bottom. So we can edit the fairing. And then if we have our proverbial engine section there. That's good. Save. Okay. Dude, what a tank. Oh my goodness. Does the skirt work like a nozzle at high enough altitudes? Kerbal doesn't have fluid dynamic simulation made. No, it just looks cool. That'd be sweet, though. Time for a static fire. My engines aren't hooked up. I don't have the thrust structure all made for this thing. That's awesome. What a freaking monster this thing is. I love it. This is great. We are going to need to do some tanking tests, though. I got to make sure this is all strong. Oh, dang. Hold on. That's where that needs to be. Does it live inside of some struts? Yeah, of course it does. All right, a couple more struts that we need to run. So from the mid tank, I'm gonna strut the mid tank to the aft skirt here. They need to be ahead of the shell so we don't get confused. The reason why I don't want them to get confused is because we got to run struts here to the aft skirt of the motor, or the stage. Excuse me, not motor. Give me 1 second. There. That should work. Now, what we can do here is dead center. We can run a strut to the aft skirt fairing plate from that tank. Have you messed around with Starbase Simulator? Pretty cool. No, I have not. And what we can do here is the same exact thing. From this tank in 4X Sim, we can go down to the fairing plate. I like putting the struts at a 45-degree angle. Angle of the dangle absolutely matters. Struts at a 45 give you some triangulation. Makes them a lot stronger. Yes, the angle does make a difference. Now that one is from the aft skirt plate to the aft tank wall fairing. That should keep that very strong, dude. Hey, there's dinner for you. Okay. Cool. All right, so save Prometheus R1. Now what we're gonna do, let's go Prometheus first stage tank test. First stage tank testing file 624.25. Save. So we got to take this, we got to put it out, we got to make sure it's strong. I don't know how we're going to do that necessarily. So I'll save a new craft file off of revision 1, set that docking port as root part, and then get rid of the control node. So now we have the first stage just sitting by itself. So I think a good thing to do here would be to fill this thing up with fuel completely and do basically a tanking test. We're 1,933 tons here. So let me take that, turn that thing upright, hit the save button, and then just so the game doesn't get mad at me, just put a control node with solar panel, a couple solar panels, and a couple of sets of batteries there, just so we can sit out and look at the dang thing. All right, so I'm going to place this first stage out on the runway with full tank of gas, with fully fueled, dudes. That's what we're doing. And let's see if that aft skirt can hold up the whole vehicle. Let's see. Who thinks it's going to do it? Who thinks EJ knows how to do this? Cryo, 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 spin prime, spin prime, spin prime, static prime, spin prime, static prime, spin prime, cryo test. It'll survive? You think so? 1,900 tons of fuel resting on a fairing. Let's see what happens. %60 of the time, it'll work every time. That doesn't even make sense. Oh. Damn, I'm good. I still got it, man. I still got it. All right. Now, anybody here familiar with the Starbase program? Starship program? What did they do? Remember the bird cage? Remember the bird cage? What does the bird cage do? Who's the expert? Let's see. Who knows? Test loads on the rocket. Okay. Increasing gravity twofold. 2 G's of load. Oh. She's jostling around, dudes. See that? Kerbal doesn't have soft body physics, meaning that stuff doesn't crush in KSP. Like if we were playing Beam and I ran my car into an abutment, it would crumple. Kerbal doesn't have that. It's a hard body simulation. Whenever you see the Kraken lurking, right there, see that? See how it's moving around? That means that part would get crushed. It's not strong enough. Not strong enough. The rest of the vehicle seems to be just fine, though. Nothing else is moving around, from what I can tell. Let's try 3 times the gravity. Failure. See? Failure at 2.5% load. The aft skirt came off. That's what happened. Positive. The aft skirt broke off, right? It snapped. And what you're seeing here is it colliding with the 5-meter fuel tanks. It connected with the 256 and the 64, 512, 64, 256. The back broke off. Actually, the front fell off. So, what did we learn here? Well, we learned that this stage will fail at 2.5 Gs of acceleration. It'll explode. It will not be able to handle that load. It just didn't fail where I really thought it was going to fail. That's very strange. I was not expecting that. It failed up top. If we look at the crash log, 256, 64, 512, 64, 256. See it again. That's very strange. The top failed. That is not where I was expecting it to fail. That's bad analysis on my part. Why would that happen? Why would the top fairing fail? I need to see it again, dudes. Very weird. Hack gravity. I see where I screwed up. Yep, I see it. So down here, down at the bottom, guys, if we go down here, actually throughout none of this, here's the big problem. No fairing shell is strutted to another fairing shell. That allows the fairing shells to move around independently of the fuel tanks, that's the behavior that we saw down here. See? The fuel tank is staying put, but the fairing shells are moving around the stack. That's not good. Let's zoom out and let's push this to slowly up and we'll see where it fails. Where does the explosion happen? It failed at 2.5 before because I shock loaded it. We're past 3. Slowly ramping up the clamping force. Four Gs. Any of the shells moving independently of each other? That one is. What about at the common dome? No movement. I didn't revert. No, reverting doesn't. Reverting to hangar does not cause memory leak. Reverting to launch does. 5G load here. Interesting. "5G sustain," and we don't have metal fatigue in KSP. There's no metal fatigue unless we tried to time warp right now. Then it would break it. But we're not going to be time warping under 5G load here, so I'm not too worried about it. Oh. Hey! Pop the top! Once you pop, the fun don't stop. Same exact behavior. Interesting. Interesting behavior there. Okay. Failed at 5Gs, but it failed at 5Gs after a certain amount of time. That would be an extremely unlikely thing. I think I know the issue here. I'm pretty sure the fairing shells, the actual fairing arrow shells themselves, are not strutted to each other. Now, with a fairing, you have two big components here. You have the aerodynamic shell, and then you have the plates. Now, the plates are auto-strutted to each other, so I'm not worried about those breaking, but the shells sometimes can move independently of the plate. They do move around. Like, the fairing plate can stay fine, and the shell does move around. It has moment over the fairing plate. So we're going to leave that like that. We're not going to mess with this anymore. We don't want to modify this file because we have the master file in the Prometheus R1 file, right? Don't modify this. Don't do the fix here. Do the fix in the main craft file. So, let's take a look. Are any of my fairing shells connected to any other fairing shells? I don't think so. None of my... Oh, jeez. Okay, hold on. None of my struts are connected to... I have no strut connecting the tankage to the fairing plate. So, you know, that's good. No wonder this part failed. It says made in Japan. Now, the tanks are just straight up attached, but yeah. Now, it would probably be wise here to strut that. You can't strut a fairing plate to a fairing, like the fairing shell to a shell. You can't do that. You can't attach to a shell, at least with a root. You can attach arrow shells, fairing plates to shells, though, if that makes any sense. So, here's what we'll do. Let's add another set of struts. What these struts are going to do is they're going to be in 4x symmetry, and they are going to strut directly to the fairing that's attached behind them. Like that. So that plate is now strutted to there. Now, I'm not 100% sure if that's gonna... I mean, that's gonna help. It's gonna keep them from skitching on each other, which is good. Okay, now let's go down to the center fairing plate right here, which is middle of the stage. Do the exact same thing. Go straight up with a strut. I don't know why it wouldn't let me attach the strut straight on. If I had to guess, it's because the fairing segments are in two half segment. Don't worry about that. If you select the fairing, you can select the sides here. If they're in two, you'd usually put the seam at the top. Like that. Kind of like that. It's pretty good, man. Oh, no. No. That's good. Yeah, I like that. Okay, so now we have mid fairing strutted to aft fairing, and then I do believe I already did the aft skirt strutted there, but I did notice that this thing didn't really it moved around a lot, which I don't like. What we can do is take the back fairing piece and we can strut up to the skirt from there. We're gonna have to work our way around those struts, but that's okay. Nope. I seem to remember being able to radial attach to this stuff, but I guess not. We did see these tanks moving around independently of the bearing piece, so I'm going to put a 45 strut right here which is at the end of this stack hierarchically, I guess is the right way to say that. If I could strut the back, the common aft dome here to that, I would, but that's the closest we're going to get to it. What, in your opinion, has the best economy for space in the next 10 years? Pharmaceutical, Jaded. Look up what BARDA space is doing. You can get the big pharmacy. You can get big pharma involved in space flight. It goes from like a $1 billion industry to like a multi-trillion dollar industry, man. You can get okay. So long story short, guys, what I'm trying to tell you, if you don't understand anything, if you didn't understand what I just said. You can make more potent drugs if you make them in space. That was proven by NASA in the 80s with an experiment called the Continual Flow Electrophoresis System, or CFIS for short. Oh yeah. Yep. the reason why is because when you go to synthesize a drug in space, because you're in a microgravity environment, you don't get as bad of cell deformation. Because under the force of gravity, stuff bends under load, like the load testing that I'm doing on my tank right now. Walter White about to own his own space station. Yeah. Need more triangulation. That's right. Breaking Bad in space. That's what I'm trying to tell you. Now, that'd probably be better for like not cooking meth in space, because that's where a lot of you kind of went to. But you know, like you could synthesize like cancer drugs or something, or like a vaccine or whatever, like you know, stuff that like helps people. I mean, but then again, you could make the argument that methamphetamine helps people in another way. Interesting, I hadn't heard that. How many different kinds of manufacturing are better in space? Growing a plant? Actually, they proved on the ISS that growing a plant in space is very nice, because the plant doesn't, okay. So like when there's a plant that's growing in the ground, like I have my tomatoes outside. When my tomatoes grow, some of the energy that the plant makes, the photosynthesis, the mitochondrion is the powerhouse of the, okay, all right. Some of that is being used to actually make the plant grow higher, right? So you grow higher, you grow more leaves, right? More leaves, you know, get more sunlight and water, it'll grow, you know, you'll get a better yield, right? In microgravity, the plant doesn't have to grow, and it doesn't have to use it doesn't have to use a lot of its energy to grow, to like grow up. It can grow in all directions equally. So you can make more potent yields in space. Like you can grow crops in space a lot better. Yeah, it'll grow in all directions, right? And provided you give it sunlight and water, you know, that means more of the plant can be focused on the, you know, like a tomato plant. More of it could be focused on actually growing the tomatoes and less about actually holding itself up. Sure, Adam, that, yeah, I don't know. Yeah, that is an interesting argument. Let's hope, you know, people that aren't complete psychopaths prevail when it comes to pharmaceutical spending in space, huh? Anyway, all right, guys. That won't happen, you know it. I'm trying to educate people, not piss people off, though, Coltech, but you know, if that wasn't inferred from what I said, you know, like, it is being inferred now. Alright, so, when we continue working on this thing, we have to do a, I'm gonna have to do another can crusher test on the first stage, just to make sure that it works. Is that a Sea Dragon? No, Yarg, this is, so you know how the Saturn V had Nova after it. We obviously never saw that. You know, we had the Little Joe 2, Saturn 1, Saturn 1B, Saturn 5, and then Nova. This rocket was born out of a concept paper that an obscure NASA technical report document that we found that was made during the Apollo program about what a rocket is going to look like after Saturn. Like, say Saturn V does it, we build a moon base with Saturn V. Then where do we go? What do we build from there? This is a post-Saturn Class 1 baseline vehicle. It doesn't even have a name, because they never got this far. This vehicle would have 18 F1 engines in it, and 3 M1s, which are vacuum-optimized F1 engines running hydrolocks. 32.4 million pounds of thrust. For reference, the Saturn V had 7.5. Super Heavy has 15 million. This has 32. So it's the thrust output coming off of this is double Super Heavy. 980,000 pounds to space. That's 450 metric ton throw weight. That's pretty, throw mass, I should say. It's pretty good. It's a pretty good vehicle. It's pretty good. Frick Sea Dragon. You don't need Sea Dragon. We got that. We don't need that. I mean, Sea Dragon is actually a lot simpler than this, but yeah. Yeah, there you go, cheeseburger. How's Massey's looking? Not great. A crane fell over today, Big Poop. Yeah, somebody was lifting some debris out of the way from what it looks like, and a crane fell over. I hope everybody's okay. That's like sending an A380 or a big boy in the payload fairing. And this thing does have a big enough payload fairing to do it. Look at the payload fairing. The PLF is like 150 feet tall. Guys, that's a 50-meter tall fairing. Fairing. 18 meters wide. 50 meters tall. You could launch a skyscraper in this thing. Was it goalie? I don't think so. $450 tons. This thing could put a super heavy, albeit unfueled, into orbit. Because frick you. In KSP, do the fairings have aerodynamic properties? You bet your butt they do. That's why I do this. Better aerodynamics. So, I'm making a Kerbalized version of it. We're calling it Prometheus. And I just got done doing some proof testing on the first stage and found some places that make it unhappy. How do you simulate M1s? Rhino engines are pretty damn close. Pretty damn close for a Kerbal equivalent, dude. It needs double the thrust though. But don't worry. We can make the engines have more thrust. I ain't worried about that. Is there a hard limit on how big of a rocket you can build in KSP? I would say the hard limit is probably a rocket that's like 2,500 meters. But you'd need some mods to build something that big. You're not going to build a rocket that's 2 kilometers long in an SPH that's like 500 meters long. Okay, fellas, we got to do more proof testing. You know what? If it doesn't cool off in the garage, on the other side of Space News, if you guys don't mind, I'd like to keep going with this. We're on a roll. I'm going to take a break. We'll do some Space News, and then, you know what? I think I'm going to play more KSP today. We'll work on the car tomorrow when it's not Satan's butt crack hot outside. You know what I'm saying? How in the name of Zeus's butthole did you get out of your cell? I could keep the garage door open on Flex, but the sun's gonna shine in the garage. The name of Zeus's butthole that you get out of your cell. We ask because that might help us in our present situation. Maybe. Yeah, if we complete some proof testing here for the stage. Here, hold on. If we complete some proof testing here for the stage, then yeah. We'll, yeah, we should be able to make some pretty, should be able to work on the engine section, and then we can go fly the first stage. It was good having the time to hang with you again. Of course, Adam, you're welcome in here anytime, buddy. That's pretty sick, dude. That's pretty sick freaking stage. Wowzers. Okay, cool. Let's save. Go down to KSP. All right, guys. I'm gonna take 5 real quick. I'm gonna go grab something to eat, and I'm probably gonna take a cold shower because actually, you know what? I'm not sweating as much. The fan is actually working, despite the temperature in here. It is taking the humidity out of the room, which is good. It is getting hot in here, but it was 60% humidity when I started. 60% humidity at 70. At I think it was like 79 degrees. Now it's 50% humidity at 89. I'll take that. That's fine. That's less heat. It's not, but I mean, it kind of is. But yeah, it feels better. Let me put it that way. Sorry for joining late. What is the rocket called that you're working on? I call it Prometheus because it's going to bring some fire to Kerbin. I got to convert that to non-freedom units to understand. It is. We started the day 25C at 60% humidity, and now we're at 31C at 51% humidity, which is a temperature increase, but the 10% humidity decrease is huge. That's a big difference. That's much less. The air has much less heat in it. It still is hot in here, but yeah, that's good. Anyway. I don't know what that means, Jeff. We'll say good. All right. Anyway, you guys know the drill. We'll start Space News at the top of the hour, and then we'll go back to playing KSP. Let's see if we can get that first stage finished today. I am going to be doing a longer stream here. On YouTube, you're going to see the VOD shut off for probably we're going to have a lot of signal for probably about 30 minutes. On Twitch, you're just going to have some music, but we're going all the way to the AX4 mission. The Axiom 4 mission, which is scheduled for 2:30 a.m. Eastern Time. We're going to go all the way to that. Crewed launch on Falcon 9. Did a long stream for a crew launch. That's old school, EJ. That's what we used to do. That's what we used to do for every Falcon 9 launch. But that's when Falcon 9 was launching once every like 3 months. So, if you're looking for car stuff, we'll probably do more car stuff tomorrow when it's not this warm. I'm kind of into playing KSP. I want to get this first stage working. We'll at least do some testing with it, you know? So I'm going to go take a cold shower and get something to eat, and I will be right back. On YouTube, stand by for loss of signal as expected, and stay tuned on Twitch for Space News in about 30 minutes. Top of the hour, so 6 p.m. It's 5:39 right now. Thank you very much for watching. I hope you enjoyed part 2. We will do part 3 for this Kerbal build momentarily, or if you're on the VOD, just click the next video. I'll see you guys in a little bit. Thank you.